your own cloud gaming PC. So before we go ahead, let's just set up the environment for it. Let's just set up a preface. So why exactly do we need a cloud PC? Because we already have thin clients, right? There are thin clients like that Think Center, like small boxy desktops, Think Center, and like Dell also has an Optiplex, like all those systems. We have thin clients always available for us. We have RDP, we have VNC, all those protocols already exist. We have TeamViewer, AnyDesk applications that enable you to access systems remotely. They already exist. But we also have GeForce Now and other cloud gaming services. So why do we need to set up our own? What's the motivation there? So well, first thing, thin clients, well, you will have to buy an external hardware, right, for thin clients. Why cannot we just use our existing hardware? We already have phones that are good enough. We already have laptops that are good enough. Why do we need external hardware? RDP, VNC, they have too high latency. So is it possible that we could somehow reduce the latency enough that we can at least play some games, right? TeamViewer, AnyDesk, all those applications exist, but can we switch to an open source solution? Something that we know does not spy on us, or something that we know does not leak our data. And GeForce Now and PlayStation Plus, all those applications exist, all those services exist. But again, you need to have an account. We don't know their terms and services, how deeply they encroach us, and how will they change over time. We don't know any of that. So why don't we just self-host something, and we know what it is exactly, and we know where the data goes, right? And I say, why not? Why should we not have a cloud PC, right? We already have power. We have the openness that we can ultimately upgrade it as we want. It's our hardware, right? At the end of the story. For security, well, I can just host it anywhere I want. If I want to host it at my home, I can host it. If I want to host it at a data center, I can host it. Wherever I feel it will be secure, I can host it. It's my hardware, right? Accessibility. We don't know if GeForce Now or any other service might go down even momentarily when we want to give, right? If it's our service, if it's our system, we know how it works. We know when it wants to be stable. We know everything about it. So why don't we just host it ourselves, make it accessible enough that it's ready in 2 minutes? All we need is internet connectivity, because you will need internet connectivity for any of the existing solutions already, right? So why don't we just have a few extra nice things on top of that internet requirement? So I'll go through a story, and here are a few milestones that I'll cover. So the first milestone is how to use remote desktop protocol to access PC over LAN. And over time, I will cover various protocols, and the second half of the talk will talk about various optimizations needed to be done on top of the latest tech stack that's Tim currently using. So the rest of the story will look like this. So we'll try to access remote desktop protocol over the internet, and then we'll go over GameStream. So NVIDIA GameStream, how to use that in our own self-hosted system. And after that, we will explore Sunshine, which is a new application. And then optimizations. What optimizations Tim needed to do in order to make it reliable and accessible over the internet at all times. So this is Tim. Tim loves to game. Tim, right now, it's 2015, and Tim has recently started his summer vacations. He wanted to game, but for some reason, there's construction going on in his room. So yeah, he cannot game. Wouldn't it be nice if Tim could just play games, right? So, well, Tim tries it out. Tim sets up remote desktop protocol. He installs a remote desktop protocol application in his phone, and he just accesses his own desktop from his backyard, and he's able to play some games. It's not great because he gets around 10 FPS, but at least he's able to do it. So yeah, he's able to access it remotely, and he gets around 10 FPS at 1080p. That's the current status. Now let's explore how to access it over the internet. So it's now 2019. It has been around 3 years since Tim has completed his school and now he's in college. He's in the last year of his college and he has successfully bagged an internship. But the thing is that internship is a bit too far. It's hundreds of kilometers away from his hometown. And now he cannot bring his own desktop with him. So now he's employed at Nom Nom Corp. It's a real company, you can look it up. He goes there, it's his first day, he does great. He comes back, over a few months when he's settled in his new job, he tries to set up remote desktop protocol again. He accesses his own computer remotely, this time over the internet, and he's able to do it. Why? The answer is port forwarding. So he could forward his own port, the remote desktop protocol port, that is port 3389. He forwarded that port and he just used his own IP address and he was able to access it. Simple. But again, it reduces the quality much more. Yeah. And the status is he gets around 2 FPS. That's the current status now. So yeah, over the internet, remote desktop protocol, 2 FPS, 1080p. Now, let's explore the next chapter, which is NVIDIA Game Stream. So now the time is 2020. We all know what happened in 2020. So Tim came back to his home and he explored a few Reddit posts and he figured out there is something called NVIDIA Game Stream that has been available all along in his own system. And he explored it and he realized that he could just enable this little switch, the Game Stream switch, and he can use an application called Moonlight. What's that application? Well, technically, NVIDIA is not good at hard. So this Game Stream service only works with Shield devices. When I say Shield devices, it means the Shield tablet or the Shield TV, those kind of things. So how can Tim use his existing hardware with NVIDIA Game Stream? The answer was Moonlight. So Moonlight is an application that mimics Shield hardware, and you can use this application to enable your Android device or your iOS device, any existing device. It has a bunch of clients. You can use any of your devices in order to stream your desktop through NVIDIA hardware using NVIDIA Game Stream. So he tried it, and he could get reasonably well FPS. He got around 50 FPS at 1080p with the HEVC encoder. So now he could get around 50 FPS within his LAN. Yeah. So that's the status now, that he could access his system remotely and he got a respectable 50 FPS over 1080p using NVIDIA Game Stream. So now the next chapter is accessing NVIDIA Game Stream over the internet. So this time it's 2021, things are slowly opening up and Tim has got a full-time opportunity. So now he again needs to move and this time he's prepared again. This time he has set up NVIDIA Game Stream over the internet. So for doing that, he again forwarded a bunch of ports. The list of ports is this one. I know it's a long list of ports, but we are still developing. And Tim is not a high-level threat or a high-level asset. So it's not like somebody's targeting him. So it's okay. So he exposed a bunch of ports, and he could access his system remotely with a respectable FPS over the internet. So that's the status in 2021. Then it worked well for about a year. 2023 happened, but then we got some news. So apparently, GameStream released their end of service notification in 2023, Feb. This was around the same time when Google Stadia also dropped. I'm not sure if those two things collide, but yeah. Apart from that, people were also talking about Moonlight, and a lot of people on Reddit were complaining, but they were also discussing, which is quite rare on Reddit. So here you can see one keyword in the second line of the post, sunshine. So this is what caught Tim's eye, and he got to thinking, what exactly is sunshine? And he explored it, and he found it out that there's an application called Sunshine, and if you use Sunshine, you can expose much less ports, and you can get better, if not the same quality as GameStream. So Sunshine is an application which provides kind of the same features as GameStream. You can still expose some ports, or you can still get your stream from your desktop to your Moonlight clients, and it works the same as GameStream, and it's completely open source. So Tim set it up, and he could get better than NVIDIA GameStream FPS, around 55 FPS at 1080p over the internet. So that was the state once he set it up. The next thing is optimizations. So when I say optimizations, what do I mean? So the first thing is Tim always needed his desktop to be running. He needed his desktop to be always on, always turned on, at least on standby, but he always needed it to be running. Why is that? Well, sunshine works only when your computer is turned on. You need the computer to be turned on fully. That means you need the monitor to be turned on, and you also need the CPU to be turned on. At least these two things are mandatory. Why exactly? Because Windows is Windows, and Windows does not like headless systems. So if you want a screen to be streamed, you at least need a monitor that is actually presenting that screen. So if you cannot, yeah? Yeah, exactly. So if you cannot provide a desktop, a monitor, the next best thing you can do is plug in an HDMI monitor, HDMI dummy plug, right? So if you plug in that HDMI dummy plug, that works. That's the first thing. So that way you don't need a monitor. That's around 50 to 100 watts of power save every hour. The next thing is restoring power loss. So in order to make sure that his computer was always turned on, Timmy set up this one feature so that his computer was always available, always turned on. But it's not the best thing, because then again, you have your hard disk spinning all the time, you have your computer turned on all the time, and it reduces the life of your hardware a lot. So how to fix that? Yeah. So right now, the status is the system is always accessible because of that switch, and you don't need any extra peripherals because of the dummy plug. But how do we make sure that we don't sip power when we don't need to use the computer? How do we fix that? The answer is Wake on LAN. So Wake on LAN provides you a way to turn on your computer within your LAN. That's important, within your LAN. But Tim was not within his LAN. Tim was miles away, thousands of kilometers away from his home, but he still needed to somehow trigger Wake on LAN so that he could run, or he could turn on his desktop at home. So that's why he just bought a Raspberry Pi, and he just set up a script that could simply turn on or trigger Wake on LAN, and it could turn on his computer. But then there was another problem. It doesn't work outside LAN, right? So for that, he just set up a proxy device, which was a Raspberry Pi. The other problem was it doesn't work with a cold boot. What do I mean with a cold boot? I'm not saying the shutdown button, or I'm not saying restarting and then turning it off. I'm talking about disconnecting from power. So if you disconnect your CPU from power and then you reconnect it after a few seconds, there's no power in the CPU at the moment. Wake on LAN does not work. So this is not universally true, because every motherboard manufacturer has their own implementation of Wake on LAN. It might work better for your system, but for Tim's system, it didn't work with a cold boot. So for that, Tim had to hack it. So what Tim did is a bit weird. I'm not sure if Yeah. So for that, Tim did something a bit weird, which I can only explain through words. So Tim set his computer to turn off within 2 minutes every time it turns on. So you can think every time power is restored. So for example, every time electricity goes for a few minutes and then electricity comes back, right? The computer turns on by itself. If nothing happens, it turns off within 2 minutes. Those 2 minutes are enough for anyone to log in and then cancel the shutdown. But obviously, that means Tim always has to be on his toes when he's turning on his computer. He already has a proxy device, right? So why cannot he just script it? That's what he did. He just set up a script, and within that script, he just kept SSHing into his computer, and he would just cancel it every time the script ran. He would just cancel the shutdown, and it was all good. So this is how he figured out the cold boot problem. That's the first thing. The next thing is you all saw a bunch of ports were being exposed. So for that, he set up WireGuard VPN. And setting up WireGuard VPN meant that he did not have to expose ports. He could enter his own LAN through the WireGuard VPN. So that happened, and that way he could easily reduce his attack surface. That's the first thing. So at this point, the status quo is securely accessible remotely over the internet, around 55 FPS, always accessible, only consuming power when used, and without any extra peripherals. The next thing was that around start of 2024, Tim's ISP decided that it was time to call it quits. It was a local vendor, and he got a new ISP. At this point, everything was going great with the previous ISP. When I said everything was going great, he had a static IP address, and that's why exposing these ports and then accessing his own IP address was simple. It was easy because it was a static IP address. But this time, the new ISP put him behind a bunch of nuts, not just one nut, a bunch of nuts. And at this point, he needed something so that he could access his services without going through these nuts. And at this point, he found out about Tailscale. So he found out about Tailscale. He set up Tailscale on his own phone and on the desktop, and he was able to securely access his own desktop. If you want to set up Tailscale, the Tailscale application and the Tailscale server, the node logic is entirely open source, but the coordination server is not open source. The coordination server is the bit that connects the two devices together, any two devices. The coordination server's open source implementation is called Headscale. It is not affiliated with Tailscale, but it's available separately as an open source implementation. So if you want to try that out, you can set up Headscale on your systems, and you can use that. So he figured out that there was an application called Tailscale that could jump through nuts. And at this point, the status quo looked like this: that his system was securely accessible over the internet. It was always accessible, only consuming power when used, without any extra peripherals, and even works without a static IP address. So, yeah. So at this point, this is the status quo. So he pushes a button on his phone to turn on the PC. It triggers a script at his server. He accesses the PC securely. He logs into it, and then he plays games, logs out, and then pushes a button to turn it off. Simple. Yeah, that's it. If any of you have any questions, now would be the time. Yeah. Yeah, yeah, definitely. So Tailscale internally uses WireGuard. So since Tailscale internally uses WireGuard, you can easily secure all the communication. So it's completely secure and it's still applicable in an office environment. Yeah. Yep. Yeah, you can do that. Thank you. Yeah. Yes. Yep. Yeah. 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 The Pi KVM is not the best solution because Pi KVM exposes the screen of the desktop, the Raspberry Pi desktop itself. But Tailscale enables you to directly stream from your desktop without your server as being the middleman. So when you're using Tailscale, compared to using WireGuard, in the case of WireGuard, all the traffic goes through your Raspberry Pi and then it comes to you. So it adds a bit of latency. But when you're using Tailscale, you are directly streaming from your desktop directly to your mobile client. So there's no middleman when you're using Tailscale. That's the first thing. And the second thing about AMD GPUs, yes, Sunshine supports all the GPUs right now. As long as it has an encoder, it works. And yeah, all the GPUs have encoders at this point. Yeah. 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 Nice. Yeah. Yeah. So the first thing is all of the tech stack here is open source. So even when we are talking about it, it's still improving because it's entirely open source and anyone is still working on it. So Moonlight, the client application, Sunshine, the server application, Tailscale, the networking application, all these things are open source. So even while we're talking about it, somebody is already improving them. And personally, I cannot think of any good solutions apart from the things that are already in beta within Moonlight and Sunshine. For example, support for newer encoders, support for editing your bitrate. Like if you are in a low bandwidth network, so you can reduce the bitrate and you can also configure what resolution you want so that you can get exactly the quality that works for you in that particular situation. So yeah, there are a lot of configurable options when you're using when you're using Moonlight and Sunshine, and you can optimize it as per your requirement. So yeah, does that answer your question? Okay, what's the challenge that you're facing exactly? Yeah, yeah. Okay. Okay, so is that a bandwidth problem? Like you have low bandwidth connection, or is it something else? Okay, so yeah, you can edit the bandwidth in the Moonlight application, and that way you can configure exactly what quality works for your particular scenario. Like I can just try it out right now.
One more question, please. I want to ask about how is this going to deal with multi-user or multi-sim?
Yeah, for multi-user.
Like I have a Linux machine in my home, and my brother and I want to play together. But we with the share machine, same machine.
For a multi-user environment, I would say Windows does not let you do that. Windows does not let you access multiple users at once, but you can do that using virtual machines. So if you pass through your GPU inside a virtual machine, and then you log into the host, and for example, your brother logs into the virtual machine, then the two of you can make it work on the same desktop.
How about the next one? Like with the absolute innovation of the whole man. The specification is pretty low, so
Yeah.
about VM, like to VM to watch and have fun VM. So how can I deal with that?
Virtual machines are pretty efficient these days because of like virtualization and passing through a GPU. It should not reduce. It should reduce a lot of overhead at this point. So you should be able to do that. So yeah, you can see the desktop right now. And if I log into it, before I log into it, I'll just show you the configurations. Like what options do we have? Wait. Moonlight. Yeah. So you can see here, there's a bunch of options available for you. For example, you can set up the resolution. You can set up the frame rate, like what frame rate does your device support. For example, on my mobile device, it even shows me the options for 120 FPS. I can set up the bit rate. What bit rate do I want per second? And there are a bunch of other options. For example, I can set up the frame pacing. Like, do I want the lowest latency or do I want the smoothest experience? All those things. And there are a bunch of other options available for things related to gaming. For example, emulating your gamepad if you're using a non-standard gamepad, all those things. Using your touchscreen as a trackpad, like the standard controls that you expect, the standard options you expect from a remote desktop client, they're all available already. And there are performance stats. So if I just enable this, so that's my desktop at home. And at the top, you can see it's currently running at my mobile phone and through mobile data. I think it's no, it's on the Wi-Fi. It's on the college Wi-Fi, and it's giving me around 10 FPS because the screen is static. If I I need to figure out how to show my monitor keyboard. So once I'm able to show a keyboard, I can log into it. So yeah, right now I'm running on the college Wi-Fi, which does not have a lot of bandwidth. So there's a bit of latency because of bandwidth and other things. Yeah, it's fine. It's fine. It's secure enough. It's fine. 971 3. Yeah. So it's running right now, and at the top you can see it's around 50 FPS on the college Wi-Fi at 1080p. So now it's static screen now. That's why the FPS is low. Yeah. So this particular Grafana desktop is my server, the Raspberry Pi that I have at home. And obviously I can game as well. That's completely doable. Uh, yikes. Need to be. Yes. Yeah. So that's my desktop back at home. And what do I need? Games. I need game. Yeah. So no, I don't play Doki Doki Literature Club, but I do play Spider-Man. Where is it? Yeah, so now the connection is probably lost because college Wi-Fi. If I disable the college Wi-Fi, it should work better. Yeah. I just disabled the Wi-Fi. Yeah, so now it's much more responsive. But that's the first. Yeah, Tailsky is working. So yeah, I think a lot of people are showing up. So yeah, so that was it. Setting up your own cloud gaming PC. If any of you have any questions, I'll be at the KDE booth, so I can talk about self-hosting, setting up your cloud gaming PC, or KDE. Okay, thank you.
Thank you. And good morning, everyone. I know it's a bit too early to talk about all three technologies, and that too in a comprehensive way. But yeah, let's try it. I don't know if this will work. Okay. So a little bit about me. I'm a maintainer of Apache API 6, as you can see on my T-shirt. I used to work on some CNCF projects, which is Cloud Native Computing Foundation. And I also try to help contributors through GSOC and LFX mentorship program. Oh, it's okay. Okay, and today we'll talk about API gateways, Kubernetes gateways, and service meshes. And from what I understand, like people are often confused about these three technologies, and people often think that they are interchangeable, and there is a lot of reasons for that confusion. And today I want to clear that confusion and give you an idea about all three technologies and how you can actually use them and where you can actually use them. So first of all, why is there a lot of confusion? just like this confusing slide, we can dissect each of it one by one. First of all, like a lot of keywords that get mentioned with these three technologies, like canary deployments, rate limiting, and service discovery, are used to describe all three technologies. And all of these three technologies use reverse proxies. They are built on top of reverse proxies, so that adds to the confusion. And some API gateway projects have their own Kubernetes gateways and have their own service mesh projects, which also adds to the confusion. Like Apache API 6 is an API gateway. It's also a Kubernetes gateway, and it also has a service mesh. So it makes it a lot confusing. And there is also the other way around. Some service mesh projects may have their own API gateways or Kubernetes gateways. And finally, like there are a lot of articles or YouTube videos where people compare all three technologies and say which is better than the other, which is completely wrong. So that can add a lot of confusion. Let's start simple. Let's start with an API gateway. So when you boil it down to the bare minimum, an API gateway is just a reverse proxy that has a lot of capabilities. And an API gateway sits between your clients, which can be a UI, an Android app, or anything. It basically sits between your client applications and your application. And what it does is it accepts requests from the client, does some processing, and forwards it to your backend application, and takes the response back from the backend application and gives it back to your client. So basically, as shown in this diagram, so you have your different clients, your web apps, your iOS apps, your Android apps, and you have your APIs on the other side, and the API gateway sits between them and acts as a proxy, and it takes the request from the client applications and forwards it to the APIs while doing a lot of stuff. So it does things like traffic control, it does things like authentication, it does stuff like security, it does stuff like monitoring. So a reverse proxy with a lot of capabilities. And an example of an API gateway is Apache API 6. And I, of course, work for Apache API 6, which is a completely open source project under the Apache Software Foundation. And there are also other open source projects that are also API gateways. But there are also API gateway offerings from all major cloud providers as well. And an example that I will use to demonstrate the capabilities of API gateways and the other technologies will be canary deployments, which is like a very common use case of an API gateway. So with the canary release, what you are trying to do is you are trying to roll out a new version of your application without affecting your users. So what you do is you roll out the new version to only a small subset of your users, and the 95% of your users are stuck in the old application, and you test your new application with only 5% of your users, and you gradually increase this percentage until all of your traffic, all of your users are using the new version. So as shown in this example, so you have your clients and you have an API version 1 and API version 2, and your API gateway, which in this case is Apache API 6, routes 95% of traffic to V1 and some traffic, which is 5% to V2. So you can configure API 6 to do things like this. So let's see this in example. Let's see some actual code and configuration. Yeah. I believe you are able to see this. So this is an example of a canary deployment configuration for API 6. So what you basically have here is a route, or basically a configuration. You don't have to understand about API 6 configuration to understand this, but basically what you're trying to do is You are configuring your backend here, your APIs here, and you are giving it a weight of 95 and the other one a weight of 5%. So basically what this configuration does is it configures the canary deployment. And this is how it is done in API 6. This is done similarly in other API gateways as well. And going to Kubernetes gateways, we have this understanding of API gateways. Now, when we go to Kubernetes gateways, we can think of them as just Kubernetes native API gateways. So API gateways that work natively in Kubernetes. What do I mean by that? Basically, you will be able to manage an API gateway similar to how you manage a pod or a service in Kubernetes. So you will be able to create a manifest file, use kubectl apply, and you should be able to configure an API gateway in that way. So basically, API gateways, Kubernetes gateways are API gateways that are made native for Kubernetes. And to work with Kubernetes, to use API gateways in Kubernetes, Kubernetes provides two APIs currently. The first one is the Ingress API, which is the old API, but it is still being used. And the other is the new Kubernetes Gateway API. So both of these APIs are official Kubernetes APIs that can be used to configure API gateways. But Kubernetes itself does not have an API gateway implementation. Kubernetes only has pods, services, that sort of abstractions. And when we go to the Kubernetes environment, our APIs are now pods and services inside a cluster. So when you look back into the API gateway configuration, we had multiple APIs, and when we go to the Kubernetes land, your APIs are usually pods and services which are running inside a cluster. And you have an ingress or a gateway that routes the external traffic inside your Kubernetes clusters. But like I mentioned, like Kubernetes does not have an implementation of this API. And that is where ingress controllers come into the picture. So API 6 is an API gateway. API 6 plus API 6 ingress controller is a Kubernetes gateway. So while Kubernetes does not have an implementation, API gateway projects can bring their own implementation into Kubernetes. So if you want to use the Kubernetes gateway API, or if you want to use the Kubernetes ingress API, you have to use it with an implementation like Apache API 6. So what this ingress controller does is it takes Kubernetes configuration, which is written using the Kubernetes ingress or the Kubernetes gateway API, and it converts that into API 6 configuration, the configuration we just saw before. Basically, the ingress controller is a translator. All right. Now let's look at our example, which is canary deployments. So similarly, you have your clients and you are trying to route traffic between two versions of your services. The only difference is that we are trying to route traffic inside Kubernetes cluster. All right, let's see how we can do this in API 6. Okay, first we can see through the ingress API. So what we have here is the canary deployment configuration defined through the ingress API. So you can see the kind is ingress, and this is an official Kubernetes API. And you have configured some backends, which is your application you want to route traffic to. And you configure the canary release in the ingress API through custom annotations. So you can have custom annotations like this, which sets the weight. But one problem that people had with the ingress API was they were stuck with using a lot of custom annotations. So they wanted to do something more Kubernetes native, something that is more easy to do. So what people came up with was custom custom CRDs. So this is a configuration that is specific to Apache API 6. As you can see, like it is provided by Apache API 6. It is installed as a custom resource. And this type of custom resource is called an API 6 route. So basically you are defining a configuration that is specific to Apache API 6. And it more or less looks the same as we saw before. Like you are configuring different backends, and you are also giving them a weight with which you want to route traffic to. So it is pretty human readable, but it can be read by API 6 as well. But the problem with this is that this is specific to Apache API 6. So if you want to use some other ingress controller, you have to like manually change your configuration. And this might be simple for one or two configuration, but if you have a lot of configurations, you are stuck with one particular vendor. There is vendor lock-in, and that's where the gateway API comes into the picture. This is a relatively new API. This just reached V1 stage. This is an older configuration. Now it is the V1 version is available. But what the gateway API lets you to do is like it lets you configure ingresses in a vendor neutral way. So as you can see in this configuration, there is nothing mentioned about that is nothing specific to Apache API 6. So basically you can take this configuration and use it with any implementation of the ingress API. So the configuration looks more or less similar. You have multiple weights, you have multiple services, and you are routing traffic between them. And finally, let's talk about service meshes. So we talked about API gateways, we talked about Kubernetes gateways, and they were more or less similar in a lot of sense, because API gateways and Kubernetes gateways worked across application boundaries. You were talking about traffic from your clients to your application. So that is the application boundary. You are talking about the north-south traffic. But service meshes are fundamentally different from these in that it cares about inter-service communication. So a service mesh does not care about the communication between your client and your application. It is more concerned about how different services within your application communicate with each other, which is east-west traffic. So this diagram will make more sense. So typically microservice applications have different services. And what a service mesh does is it abstracts the network layer out of the application. So as an application developer, you can only care about building your APIs, building different microservices, and you can leave the networking to the service mesh. So typically how a service mesh does this is through sidecar proxies. So you have different proxies that sits with your application, that sits with your services, and it handles the networking. So this layer of networks is called a service mesh. So each service communicates only with its reverse proxy, with its sidecar proxy, and these sidecars communicate with each other and forms the network. And you can have a service mesh control plane which controls this network, and this can be inside or outside the Kubernetes cluster. So there are a lot of popular service meshes out there, and all three of these are open source. The first one is Istio, second one is Consul, and third one is Linkerd. All three are open source, and all three follow this sidecar model. But you might have heard about eBPF, which is quite popular, and this is eBPF has enabled a new type of service mesh to evolve. And one such service mesh is called Cilium. So our traditional service meshes, the one we looked before, have one sidecar for each of your application service. But Cilium does things differently. So Cilium uses eBPF to work at a kernel level. So it does networking at a kernel level. So instead of having to have a single proxy for each of your service, you can just use a single proxy and directly directly network through the kernel. So it makes it much more efficient. And the future looks quite promising for eBPF based service meshes. And we have to wait and see like how it will turn out. An interesting solution that comes is by using service meshes and API gateways. So service meshes handle east to west communication, as we saw, between different services. But you also want to handle the communication between your clients and your services. So for that, you need gateways. But you can have a situation where you can use best of both worlds. You can have gateways to handle the north-south traffic, and you can also have a service mesh with it that handles east-west traffic. So this is an example of that. The ingress gateway handles traffic into the cluster, and the egress gateway handles traffic out of the cluster, while the service mesh handles communication between your services. And service meshes also support canary deployments, and this is quite similar to what we saw before. So instead of routing or splitting traffic from external services, you can split traffic from one service to another in a canary fashion. So the configuration kind of looks similar. So this is how the configuration looks like for Istio. It looks kind of similar. Like you can set up waits, and you can configure different services to route these waits to. So the problem with the configuration that I showed you before was that it is specific to Istio, but we want the freedom to use any service mesh. So if we want that, we need to have a standard API for it, and that was the intention of the service mesh interface project. So it is a set of CRDs that defines an API for configuring service meshes. So basically, you should be able to use the service mesh interface API and be able to configure any service mesh. So you can define what your service mesh should look like through this API, and any service mesh will be able to implement it. But this project kind of failed, and only a few projects participated in this project, and it gradually became less adopted. So this project is no longer there. But the good news is this project is merged with the Gateway API project. So there is a new initiative called the Gateway API for Mesh Management and Administration, GAMMA, which tries to bring the service mesh and the API in the Gateway API project together to create a new API within the Gateway API that also lets you configure service meshes. So basically, you will be able to use one single API to configure your gateways as well as your service meshes. And one of the key enabling factors of this new initiative is that Istio, which is the most popular service mesh project, they plan to use the Gateway API as their default API. So in the future, you'll be able to use one single API to configure all of your Kubernetes networking needs. And yeah, as I mentioned before, the service mesh in the interface project also joined with the Gamma initiative. And you can use canary deployments. You can easily configure canary deployments through this. So yeah, that looks like this. So this is similar to the configuration of the gateway API, but the only thing different here is this uh, is this uh, 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 is this is this thing called parent refs, where instead of your parent being the client, it is another service. So instead of a client to service communication, this is a service to service communication. That's the only difference. Basically, like you will be able to use a single API to cover most of your needs. Yeah. So the question is, what should you use? And I can only give you a very diplomatic answer that it depends. Yeah, it depends, but it depends on you. Like it depends on what you are trying to do. So if you are trying to set up traffic routing, if you are trying to set up authentication, if you are trying to set up all those things for your client to service communication, then an API gateway might be what you need. If you are trying to do this in Kubernetes, then you might need a Kubernetes gateway API. You might need a Kubernetes gateway. But if you are trying to set up communication between your services, if you want to set up a networking layer for your services, you have a lot of microservices, then a service mesh is what you need. And if you need both, then you might need a service mesh as well as a gateway. So it actually depends on what you are trying to do. So I'm giving this talk because I wrote an article called an article with the same title, and it was quite popular. And I realized that a lot of people are quite unaware about these two technologies, and most people think that they are interchangeable. So yeah, and if there are any Chinese speakers, you can check out the Chinese version as well, which was translated by one of my friends. So yeah, if you have any questions, feel free to ask them now, or else you can scan this QR code and which will take you to the blog post so that you can revisit what I mentioned in this talk later. So yeah, thank you.
What is the performance implication of adding so many sidecars and the API gateway to the whole system? I would imagine that it add a lot of like latency to the whole network and the microservice, especially when there are a lot of microservices talking to each other using sidecars.
So yeah, there is a lot of performance implications for using a service mesh. So there is actually a project called Service Mesh Performance, which tries to benchmark how performance changes with service meshes. But yeah, like as the number of services increases, the performance impact also increases. So I think it's a trade-off. If you want more capabilities in your network, if you want to do more granular things in your network, you might want to use a service mesh, but there is a trade-off for performance. But and that's another reason why sidecar less service meshes like the eBPF service meshes are becoming more popular, because they are more performant than sidecar service meshes. So yeah, there is always an implication in performance here.
Okay, so you guys feel free to meet up with Navendu anywhere, during the event after this. Okay, so thank you very much for your time. So we're gonna come right to the next section. So today we'd like to welcome Mr. Thanh Pham from he's cloud engineer from Viettel Solution. As you know, Viettel is one of our leading technology company in Vietnam. He's a highly skilled and dedicated cloud engineer, and especially in Kubernetes. So he's going to talk about designing, implementing, and also maintaining Viettel Kubernetes engine. Okay, so in the meantime, there's actually QR code for translation on the wall. So you guys, if you need some, extra help in terms of languages. Okay, so everyone, please welcome Mr. Thanh Pham.
Hello, everyone. My today topic is Mig operator and Mig-controller tools for migrate workloads between Kubernetes cluster. So let me first introduce myself. I'm Phạm Hồng Thanh, and I'm working as a cloud solution engineer at Viettel Cloud. And my mainly focus is on Viettel Kubernetes engine. And we are currently developing a migration service which will migrate workloads from other place to Kubernetes. And today I'm going to share you guys the idea of the part of it. This presentation will have 4 parts. First, I'm going to introduce you guys what is Kubernetes migration. Second, I will introduce how we can migrate the workloads. In the third part, I'm going to show you guys 2 open source tools that I use for the migration process. And the last one, I have developed a migration operator to manage the life cycle of the process. So let's jump into the introduction. Um, what is Kubernetes migration? Actually, there are a lot of theory and detailed answer in the Conveyor project. It's open source, and I have the link down below. But today I'm going to just talk about the one definition, migration workloads between Kubernetes distribution. So for example, I want to migrate from GKE or EKS to a Virtual Kubernetes engines. Um, why and what should I do to migrate the workloads? So the reason, there are 4 reasons here to change your Kubernetes engine cloud provider. The first one is because of the difference of features and price. Um, this one is easy to understand. The second one is because of infrastructure. So for example, in Vietnam, um, Viettel has the best infrastructure for storage, for networking. So if you move your Kubernetes engine to Viettel Cloud, the latency may be lower. The third reason is because of government policy. So Vietnamese government has a lot of policy to encourage domestic cloud provider to develop features. And the last one is human resource. So if you are working at a international company, you of course you want to have a English supporter, a technical supporter. But if you are working in Vietnamese company, then a Vietnamese speaker is your best choice. So um, there are some other use case for you to use the migration service. The first use case is multi-cluster. So if you have multi-cluster in a multi-region, you might want to migrate your application across clusters. The second use case, chain region, is already involved in the multi-cluster. And the third one is when you want to update cluster version. For example, you want to update from 1.24 to 1.28. You might use the migration service. So what do we actually migrate? I have splitted the workloads into 3 parts. So basically you have to migrate these 3 parts separately, but not gonna talk about it much in this presentation. You can contact me later for the technology. So the first one is built-in resources. This is the easiest part of the migration. Most of the time, you're not gonna meet any problems when you migrate this workload. However, with the second one, it's a little bit hard for you to migrate, since container image and data is actually stored outside the cluster in some remote storage. And for the first part, you have to choose carefully the custom resource and custom resource definition. For example, if you deploy your cluster in Google Cloud, there's a group of custom resource definition that Google developed to manage their cluster. And this CRD is very useless. Like it cannot be used anywhere else outside the GK cluster. So I have 2 migration approach for you to choose. The first one is direct migration. So the concept is really simple. You just have to expose the cluster to the over the internet. And if the two cluster can communicate with each other, you can have tools like async or clone to migrate the data, transfer the data between clusters. Um, the the advantage of this approach is it is really fast, and it has a lot of tools supported to even open source tools. You can search it on Google, and but if you work in a organization that has a lot of sensitive data, um, I don't recommend you to try this approach because it's had a lot of risk. So about the security risk, because it's public over the internet, so attacker can attack your channel easily. And maybe if you have a unstable network, the data will be lost. The third one go solution. So if you are migrating, there is some downtime and you have to wait until the migrate process is completed. So I have another choice, which is indirect migration. So this approach uses a backup and restore mechanism to migrate workloads. So as you can see here, this is a source cluster, and you will back up the all the resource to a backup storage, and then you restore it in the target cluster. So in this approach, two clusters are not connected directly to each other because they have a backup storage in the middle of the way. And a lot of backup tools have more secure way to transfer data. So the advantage is it lower the risk compared to the direct migration, and it had less downtime with incremental backup. So in Kubernetes, if you use incremental backup, you might not have downtime until the last backup. And for the disadvantage, it has less supported tools. So for Kubernetes, I only found one stable tools, which is Vero, that I will introduce in the next part. The progress is complex with many, you have to monitor the progress. And it might be an overkill solution if you have just only stateful sets or simple, stateless sets, or like a simple application. So let's move to the open source tools that I use. The first one is Vero. So Vero will handle the backup and restore logic. As you can see here in the right hand side here, we have they have installed the Vero into their cluster, in the two cluster, and then it will back up and restore via a middle repository. And it is a open source of VMware Tanzu, and it also support for data migration, as I mentioned in previous part. So Hrittik and Copia is a plugin for Vero to migrate data, even if it outside of the cluster. However, Vero has limitation, so it handle the backup and restore process, but we still need to manually create the backup and restore, and it has no migration workflow. So basically, Vero just handle the backup and restore service. Then I found the OpenShift open source tools for migration called Mig-controller. And I have a link GitHub here. You guys can check it out. It has a lot of feature, so it automatically create backup and restore when you want to backup and restore. You just need to apply a configuration, and it gonna create it automatically. And it has a migration process. It can check for failure in the middle of the process, and it also had rollback feature because when you migrate to another cluster, it might not be compatible for the old version. So the rollback feature is very useful. However, the process is not fully automated because I'm working in a cloud provider, so we want to have a fully automated product. So it also has no discovery service for customer to check whether their workload are up or not, and it cannot handle some special case. For example, here we have storage class conversion. So if you migrate from other cloud provider to Viettel Cloud, you have to change the storage class to store data, and this one cannot handle it. So I have to develop a so here the Mig-controller will be deployed in a target cluster, and it will control the backup and restore workflow of the Vero. Still, I have to um, develop a operator to manage the whole life cycle. So the migration operator will have three main functions. First is manage life cycle of Mig-controller and Vero in multiple clusters. So we don't we don't work with only two clusters. We work with multiple clusters. So it is a very important factor. And what it mean? What does it mean? It means that we will install the Mig-controller and Vero inside of the cluster automatically, and we will after the migration complete, we will clean up all the resources that we have created. The second function is manage migration process. So when users do the migration, it will manage and maybe notify and alert users for the process. And the third one is communicate with front end, because we are cloud providers, so of course we need to interact with the UI. So how can it deploy the instance into the cluster? So we have qconfig of the two cluster, or maybe the service account token for the operator to discover resource and then insert the ham release. So we will use ham release to deploy the Mig-controller and Vero instance into clusters. And after that, we will apply some custom resource of Mig-controller to automate the migration process. And also we will monitoring the migration process. After it completed, we will delete the ham release and clean up other resources for customer. So that's that's the end of my presentation. You guys have any question?
I see that all the trade-off between open source tools and I have a questions that which open source tools do you prefer? Thank you. Yes, the two approach.
So actually, I am focused on the indirect migration approach
Where
with
it is.
these two open source tools.
Yeah.
And I have to combine them to and if you want to mention about the direct migration approach, this approach is suitable for people who want to study, who have like simple application in their cluster, or maybe a statement application that can easily to be deployed. But if you have sensitive data, you need to um, have a more secure way, which is backup and restore.
So most enterprise nowadays use indirect migration, right?
Yeah. So most enterprise will backup and restore by hand, I mean manually. So
Manually. Yeah.
I will automate the process.
So yeah. Yeah. Thank you.
Any other questions, guys? Okay, so thank you very much, Mr. Thanh. Very interesting talk. So you want to open your slides from here? So let me check. So have you read the speaker journal? I think they store the slides on eBPF. You have an hour. I think you should be able to connect. Okay, sure. All right, so I would like you guys to welcome Hrittik. So he's an advocate, and he's also currently an CNFC ambassador and platform advocate at Love Labs, and who had previously worked at various startups, helping them scale their content efforts. So everyone, please welcome Hrittik.
Yeah, so hi, welcome to my talk. So it's about open source dev containers. So before I start my talk, has anyone over here heard about dev containers? Anyone? Okay, one person. That is a good number to start with. So a bit about me. This is me. And I'm a platform advocate at Loft Labs, and I'm also a CNCF ambassador. I'm coming all the way from India for this conference, and I'm very excited about this. So before we start, I want to talk about the traditional ways, like how things were before dev containers were. So a raise of hands if you have faced this issue. So you have a project which you want to run on your machine, but your office laptop sucks. So anyone who has ever faced this issue in their corporate or in your college? Anyone? Okay, couple of hands over there. So yeah, this is a very common problem because most of the time the hardware outdates itself. This is because we are advancing very fast in the software side of things. So the hardware is kind of lacking, and mostly you can't always upgrade your laptop. So apart from that, there were another limitations as well. For example, as you are getting onboarded into a new company, you need to go through all the documentation, all the steps, all the make files to make sure your project is running. Even after that, there might be a scenario you are not doing the steps correctly or there is some fault in the steps. So you can't declare the state of your development environment. So there was no declaration over there. Next is isolation. You might be running some Python version 3 or sometimes a Python version 2. And even in that, you might have different isolation requirements. Like you don't want them to mess around your environments. There is something called Python PyEnvironments or ENV. But apart from that, a lot of languages don't support that. Even after that, you might have different database versions and a lot other things. So there is a requirement for isolation over there. Next is, as we were discussing, there were different dependencies and different versions over there. So when you have different dependencies and different versions, it becomes very complicated. So there is something called Docker for your production workloads. But the question is how you can use that in your development environment as well. So one of the last main concerns was portability. Suppose you are running your workspace or your development environment locally, and you want more power, more hardware, more GPUs, more TPUs, something like that. So how can you pull all those environments and push it to your cloud so that you can access more powerful hardware in the cloud? You can't just go and create a VM and then assign and create all those steps. So that becomes quite complicated because you need to manage all the steps again. So you want to automate that. And all those boils down to repeatability. You want to repeat your infrastructure and your work environment as fast as you can. The benefits are that whenever there is a new team member in your company, they can go and do this easily. Apart from that, um, your infrastructure. You can upscale or downscale your infrastructure as soon as you want. This is like when you need the cloud power, you will have that. When you are doing small operations locally, that is okay. But when you need something more specific, more powerful, that is also there for you. And all of those boils down to one common thing. That is the developer experience. As developers, one of the most important things we do is build things. So you will want ways to build things instead of figuring out a lot of other things. So the main focus is to build things, and the main focus of automation over there is to make sure you're building things without any obstacles. So what is the solution for that? Before we go to the solution from that, have anyone over here heard about Terraform? Yeah, a lot of names. So what is Terraform actually? It is a way to show or deploy infrastructure instead of clicking buttons. So it's self-documenting. So in a file, a TF file, you can file all the things which you can document. Uh, It doesn't have a wiki state page, so it's like you can deploy and define your state inside a file, and it helps with onboarding. Like for example, if you want a specific infra on your cloud, it is just as simple as deploying that infra using a deploy command. So I want to introduce something similar, but for your developer environments. So this is called dev containers. So this is like a simple JSON, but it looks complicated. So it's very simple if we go through. So as we see, we are using a Python image to create a 3.11 workspace. And then we can add extensions over there as well. Apart from that, we can specify the ports which we want to open up for our workspace. These ports can be opened up through cloud or on your local Docker. And lastly, you can create a post create command. So it will work. So whenever you go and create a new dev container JSON, you define your state of your workspace. So whenever you create this, those steps will automatically happen. And when you create this, you will have a workspace with Python 3.11 inbuilt. So this standard, this is an open source standard used by GitHub, Codespaces, and DevPod as well. So let's understand the architecture a bit. So whatever we do, the architecture is one of the most important things. So there are two types of containers. One is a production container, and here we are talking about development containers. Production containers are the minimal footprint things because we care about security over there. So as you see, we just push the compiled application over there. But in dev containers, we try to focus on a bit more. So we focus on these 4 layers. One is the OS and runtimes. Second is the compilers, the debuggers, and your extensions or VS Code and all those things. So you can have an environment in which you can develop instead of an environment where you are shipping. So this is like a virtual machine in which everything is there, but on a smaller memory footprint. So now the question is, dev containers are something like how you define your coding environment in a simple terms. So how can you use this? So here we want to introduce something like DevPod. So DevPod is a way by which you can go and create your workspace. So workspace are your like coding environment, and you can just go download it and use it. So the advantage of something like this, which is open source, is you can connect with Google Cloud, Amazon Cloud, anything, and you can use any ID you want. Like for example, you are using VS Code, CDM, or anything like that. So you can do that, and there's a lot of portability. For example, sometimes you are using on GCP, then you can use that locally as well. So the friction point of going and running all those commands to create a workspace diminishes. So yeah, this is kind of a star growth right now. So this snapshot was on April 7th. So we have seen a massive adoption on how people are using this and growing using this by creating a lot of workspaces. Next is like, how can you use DevPod? So DevPod ships as a small desktop application, which you can download it, and you can create workspaces over there. So workspaces are like your dev environments, as we discussed, an environment in which you develop, and it contains all your tool chain as well as all your coding requirement, like your language, your databases, and everything. So you can define everything using that dev container JSON, which we were talking about at first. And lastly, there is something called providers. So you have created the workspace, but where do you want the workspace to exist? So there comes the concept of providers. You can have the workspace to exist in AWS GCP, on your local machine, on a Kubernetes cluster that is hosted by you, on Terraform, or anywhere you want. So there are two types of providers. One is machine providers, one is non-machine providers. I won't go into the details, but because that is not important. But in summary, with DevPod, you can just focus on your providers and your workspace to run anywhere you want, where there is a machine. And how do we provision a machine or a workspace? So you go and talk with your DevPod CLI or your DevPod tool, and it goes and creates a machine on your provider so that you have a working workspace. And so how does the cloud communicate with DevPod? So this is your local machine. This is the cloud. So it works as a simple SSH connection, which is encrypted using the DevPod channel. So it's secure as well. And you can run this. The best part is that you can run this under your intranet as well. So you don't need any access to the public IPs because that increases our security over there. So, like in summary, what are the use cases for something like this? First is fast onboarding for your teammates. Like for example, whenever we join a company, the first thing is we go through the documentations and all those things to make sure all the systems which we have built are working on your local machine. So whenever there's something like automation in that front as well, you can just go and create the experience, like you can go and click. And not just for your company, but for open source projects as well. The CNCF is very interested in doing this because we want new contributors to come through the projects. So people are using dev containers so that people can just define the environment and they can use it. Next is cost savings. So there are a lot of tools in the market right now, and having your own VM is way cheaper than those tools because you are just killing the abstraction layers over there. And again, as told, you can have the cloud power when required. So I will have a small demo over here. So if you are interested, you can download DevPod over here, add your provider and launch dev containers. So this is a QR code of DevPod website. I will wait a couple of seconds if you want to scan it. And also I've kept a couple of stickers of DevPod over here. So when you, after the talk, you can collect it. Okay, so this is a demo. So this can be your, this is a CLI, not the CLI, but your desktop application. So you can just go and add any Git repository over here, which complies with the dev container standard. But for the sake of simplicity, we'll just go and take a simple example of a Go app, sample app, and then you can connect your provider. So the provider can be any provider, as we discussed. So here we are talking about GCP, and you need to add your project, the zone. Apart from those, you can add more specifications over here. For example, if you go in the cloud option, you can discuss and decide your machine type. So if you need a machine with a GPU, you can select that. If you need a simple machine for your simple workloads, you can do that. And also the most important things is like, you can inject your credentials from your local machine to the workspace. So for example, you have your local Git and Docker credentials. So you can inject that to the workspace over here. Yeah. And also you can define the network and subnetwork over there for your requirements. And then when you go and click over here, you can select a lot of IDs. So we are always expanding the number of IDs we support. But there are a couple of JetBrains and VS Code IDs. Also Jupyter Notebook and your fleet from, yeah. Then you need to go and put a workspace name over here. And then also there is something, a concept called pre-build, in which you build all your containers and you can use that. Once you have done that, you can just go and watch the Google Cloud Console, and you can see there is a VM coming up. So this is the VM in which your workspace will be running. So as we see right now, what will happen is like, you will see there will be a container coming up in the portal, and it will pull all the image layers. The image layers will be a Golang image layer, because we have a Go image. So let's fast forward this. And now, as we see, we have a working workspace with a Go 19.1, as we desired in our state. And here you can just use the workspace, for example, for your development, and as well as forward the ports, so you can access a web UI if you are defining something that in your API. And then to delete, it is as simple as going over here and deleting the workspace. Once you do that, you will delete the VM as well in which your workspace was running, as well as your local instance. So in conclusion, DevPod defines your workspace by managing the infrastructure. So whenever you create a workspace, it's focuses on creating the VM as well. Second is, you can have inactivity timeout. Like for example, if you're not using the machine for a couple of hours, you can make sure the machine shuts down so that you save on cloud cost. Secondly, when all your workspace from the machines are deleted, it will delete the machine. And the last is, you can check DevPod as an OSS solution for providers, code editors, and more for customization. So those are a couple of tweets I found a week ago, which I could put in, where people are using it and moving the pace of their projects. And last but not the least, you can, if you have any more questions, you can ask me or join the Slacks. And don't forget to collect the stickers over here. And this is me. If you want to connect me on social, something like that, this is my QR, and I'm open for questions if anyone has any questions right now.
So like since you mentioned here, we can connect to the multiple cloud here, right? So is there any way we can identify what is the pricing belong to that one? Because when we are going to launch the VM into the cloud, right, we should know that, okay, is there any pricing involved in that? Whether it's a free or whether it's a free tier, like that, like is there any way?
So the thing is, we can't see that on the web UI over here. The reason being, generally, when someone uses cloud, they have a predefined quota over there. So if your company is kind of assigning you a predefined quota, which is counting towards their machine list. I don't think we define over here, but you can probably see that on your console, right? So that is it. Any other questions? Yeah.
Can I check for the files, right? Are they synced locally or it's only cloned from the repo and then once the machine is decommissioned, the files are also deleted? Okay, is there any way that we can stash the changes locally and stuff like that? Is that in the plan? Or? Okay, okay. So you gotta commit again.
So it is just the source of truth over here. So the state which is there,
Okay. Is there any methods or ideas of how to sync local with the?
Yeah. So the idea is you're not cloning that thing locally, you're joining that on the workspace. So the simplest thing is to sync with Git, but maybe there are some extensions which can be developing on your local machine as well as on your cloud.
Maybe you can mount a local drive to
I see. Okay.
Yeah, only if you are using a local extension. Like if you are using a local Docker extension, that can be possible very easily because you are mounting something with the local machine, right?
Any other questions? Okay, so where's your booth, Hrittik? Oh, you don't have a booth. Okay, so thank you so much for your talk. It's very interesting. And if you have any questions, feel free to contact Hrittik. Okay, thank you so much. Oh, there's stickers.
1 minute or 2 minutes. Okay. Hi, Xin Cao. Hello everyone. Today I share my topic about AI. You know, AI is very, very hot, and the population you use ChatGPT, Llama, and other large language model. This I I yesterday night, I tried to read my shell slides. Two, I know this is April 6 GTC Inveda GTC Global Technology Conference last month in American. Try to do some checkpoint and restore for GPUs. So I try to add the page to my slides. This is very, very hot. If you do some computer science, you can listen my swelled topic. Is very, very interesting. Okay, this is done. So I stand before you and try to introduce myself. My name is Luan Jianhai, and do very years developer in open source. I do some kernel, Linux kernel for 5 years, and do some hardware, Qemu and Zen. And you can find my name in KVM Zen development mail list. You can find my mails. I find this developer 506 in Oracle. So I find some security in 5 years. So and then I do some OpenEuler developer for Synthety. So you can, I don't know, you yesterday afternoon you go to the mail hole. This mail hole 里面 sorry speak Chinese. In mail hole, I try to do some other project. You know, you find the OpenEuler some A10, O2, or AI. Try to do some OS profiling, and another project AOS. Yesterday afternoon, show some AOS and the Syscale project. So maybe this project is do after. So before I do some the project, but I find interesting field to do. So maybe I try to do AI container leave migration. I don't know. Maybe you can ask me why name is container leave migration. I will know. Do you know? Why this name is not container migration, just AI container migration? I don't know. Are you 你帮我翻译一下，用那个怎么就是为什么不是 AI container，而是 container 迁移？不是 post container migration. Yeah.
Mọi người có biết tại sao lại gọi là AI Container Migration không? Mà không phải là chỉ mỗi container không thôi.
Em nói tiếng Việt xong chị gì? Em nói luôn. I think it is AI container because it has GPU. Yeah, with the normal container, it's some it have a normal container. It only have the CPU and RAM. But with AI container, we have schedule GPU for it. I think that.
Just use CPU, but AI container use some as GPU or other accelerator, maybe Huawei NPU and Google TPU for AI training or inference. So maybe we start the slides. So this is 5 chapter. Yes, okay. Container OS. I have created interesting project in OpenEuler. This is name is Cube OS. Cube OS such as AWS, the Bottle Rocket. I would know Bottle Rocket, AWS, American AWS, Bottle Rocket. Maybe you can find some Red Hat, some Core OS. Core OS. I don't know. Do you know Core OS? Core OS. Just I don't ask everything. But I just talk about the Cube OS, such as Bottle Rocket and the Core OS. This OS is just based upstream OS, but just like for cloud native OS. Why cloud native? Cloud native is very small, very security, more feeling, more migration. Maybe is very popular population cloud native OS. So maybe this is introduce of the OpenEuler. So maybe I next page. You can read the page in at yesterday afternoon. So I don't introduce. So maybe just I try introduce my project. This is Cube OS. Cube OS is container OS, like Bottle Rocket or Core OS, just the based on OpenEuler. OpenEuler based OpenEuler and the vendors is API compliant. API compliant application boundary interface is very. If you build your application, OpenEuler application can just run Cube OS and in container. So this is background. This is background. I don't introduce in detail. So I just show this is the first introduce of class OS. Maybe Cube OS in Huawei Cloud, some million instance. So maybe if you introduce the project, maybe you can fund the project and enjoy. No, don't introduce in detail. So this is CubeOS architecture and technology detail. So I don't introduce in detail. So this next chapter is why do this something. Do you know why to leave migration? You know if do some computer science, you know virtual machine leave migration. You know leave VM migration, virtual machine. If study in computer science and in do some lab, you can know virtual machine leave migration. Yeah. Okay. So, but you know why AI application use VM migration? Why? Why use virtual machine? Virtual machine is very population. Why? I just say, if you use virtual machine migration, your GPU parameter data is very. You know, GPU have 192 GB in memory. So if migration the data is very long, so maybe we can use container migration. You can translation is small data. So maybe I use Y container leave migration. This is leave migration is support reduce the support instance, just the support instance. If instance is died, or maybe the biometal try to fix, maybe I can migration my container to other machine. So 1, 2, if you have two container, one container relation with very relation another container. Here container, maybe we can reschedule this container to one machine. This is two size. Here, this is resource fragment. If this, maybe I can reschedule this container. Here, this. Here, if requires client, customer, or client try to require resource not enough. So maybe I can migration the container to another. So another biometal can enough this container. So the last is here is just which maybe I can container another here. So this is reschedule container called ability. This is another maybe you know we can do some LLM training. How long? Do you know how long we can GPT 3 1.5. How long training? How long? Training. Yeah, 训练。Do you know training? 就是训练一次多长时间？ I tell you, 3 months, 3 or 5 months. If you error, the past computing is 白费怎么说？浪费怎么说 ？Wasting. Okay. It's very long. So maybe we can do some checkpoint and store. If you 忘记一些事情做笔记，你能给我翻译一下吗？如果做一些事情，如果你能忘记的3个月前做些什么事的话，你必须得做笔记。就这个。Yes, this technology is do some log, and if you forget the computing, maybe you can redo by your log. So this is here. This is here is very 1,000 card. This is 2,000 card. This is time. Training time, you see here is fault error, is long fault error. So maybe question here. This is history, container leave migration, the container leave history. This is CIU to this year. Maybe Kubernetes use CIU this year. Maybe this is Kubernetes, the Google use plus LPC use CIU. This here is this last is ChatGPT use this this technology and 20 this years. Okay, this is CIU leave migration is entire. If you don't know the detail, maybe you can find some page in web. This is container AI container child leave migration use this. Okay. This is you see this is ChatGPT use this container, and this paper release and 20 years. Here 2 years ago, Google, Azure, Microsoft Azure released this container. This is technology. AMD tried to release the technology and the file. Okay. See? Okay. This is this year, Invenda global technology try to release the technology. Maybe you can, if you have interesting, maybe you can find the web and the public web. Okay, this is here. You can find the demo. Okay, this is solution with AI container leave migration. This is here. This is maybe upstream try to use leave migration in this. Maybe I can try this. This is container run operator created, replace with run restore. I don't launch new container, just restore the container. This is my solution. So solution is in CPU. The first step separate and marriage CPU and NPU stands. Checkpoint restore CPU. This is GPU 一些 some technology. Okay. Okay. This is pros, cons. You can detail in after the meeting. So this is NPU. NPU try to some Huawei ascend card. So this is entire. Maybe you can do something entire. Maybe you can do new container AI migration. So the last, maybe I can do some daemon. Here, this is okay. Okay, this is the GPU. This is GPU. The another GPU. Maybe I can run my container training in GPU. This is workload. So this is GPU you autos. Another, this GPU logs you can find. This is workload and running. So this GPU is no workload, no running. Wait 1 minute. The container will be run another GPU. You can here. This is no run. Here, migration the container try to the another GPU. Okay, wait. Here, this is no run. Maybe here, please wait. This is stop the AI training container. So maybe wait 1 minute, try to migration the AI container into this. Here, this log here, work run, restore the AI GPU in this. This is this is complete. If you have interest in the technology, maybe you can connect with me or with email or person after the meeting. Okay, thank you very much.
Yeah. Thank you very much, Mr. Jianhai, right? So everyone, if you feel free to come and talk to Mr. Jianhai at the OpenEuler section at our stairs. Okay, thank you very much. It's a very good thing. Would you like to MC?
No, I have my talk after this.
After this?
It's my talk next door.
Here?
So
Next
I
door?
can only, no, I cannot. I have to,
Okay.
because I have to leave immediately. My own talk, sorry. Not this time.
I'm just a bit nervous introducing Mr. Dominik.
Hello. Hello. Pretty good. How are you doing? Easier than I thought it would be. May I ask you, can you translate a question for me? For the fantastic. I want to ask the audience who is born after 2006. I'll ask that later during the talk.
Later.
During the talk. If you can help me translate that question, I'm curious if we have anybody in the audience who's born after 2006.
Okay, hello everyone. So the next talk, we're pleased to welcome Dominik. So he's going to talk about distributed async await, a new programming model for cloud. All right, so everyone, please welcome Dominik on stage.
Thank you. Thank you very much. Let me see if this is set up well. Oh, that's okay. I think we're good. I'll do this manually. All right. Thank you very much for being here. Again, I'm Dominik Tornow. I'm the CEO of Resonate. And at Resonate, I work on distributed systems. And in distributed systems, on distributed async await, a programming model for distributed systems. I started my professional career in 2006. If I may ask, is here anybody who is born after 2006? Nobody? Okay, all right. So yeah, I started my career in 2006, so that is almost 20 years ago. And in 2006, AWS, Amazon, launched the very first cloud service. That was EC2 and S3. And the cloud services changed the software engineering landscape forever. So when I entered the field, the dominant thinking about software systems was thinking in layers. We had a top layer, and the top layer consisted of a set of clients. So typically web browsers. And then we had a middle layer or middle tier. And that was a much smaller set of servers, typically web servers. And we had one database. Now, technically, this is a concurrent distributed system. However, as a developer, I don't really have to think about these systems as distributed systems. Every request is processed individually, and every request is well isolated by the framework itself, by the web framework itself, and by the database. So as a developer, you can almost think about this system as if it was a sequential system. Now, with the rise of the cloud and service-oriented architectures, applications are no longer confined to 3 layers. And today, we think about systems in terms of a set of independent and interacting agents that span across multiple machines and that also often span across the entire globe, multiple geographical locations. Now, today's applications are distributed applications. And about today's applications, we have to think about these applications as distributed applications. But there is a catch. So while distributed systems are thriving, the developer experience of distributed applications is broken. We have to implement orchestration, choreography, event sourcing, CQRS, command query responsibility separation. I don't even understand what that is. The transactional outbox pattern, event-driven systems, reactive systems, sagas and compensations, client-side discovery, server-side discovery, rate limiting and retries. And sometimes, we even write application logic. So the developer experience of distributed systems is broken. Now, but everybody says distributed systems are complex. Everybody says distributed systems are hard to build. And also every project promises you can focus on your business logic. Yeah? But what does that actually mean? Yeah? So today, let's look into the reasons why distributed systems are complex, and why distributed systems are hard, and what focusing on your business logic actually means. So from the 1950s to the 1980s, that was the era of simplicity. Developers were tasked to write applications for single machine, single core platforms. Platforms that were able to do exactly one thing at a time. Now, this era gave rise to the quintessential programming model, the sequential programming model, also called direct style. In the sequential programming model, functions call other functions in a linear flow of control. And when one function calls another function, the caller has to wait until the callee returns. A delightful developer experience. The code is simple to write, and most importantly, the code is simple to understand. Now, the 1990s to 2000s, they were the era of rising complexity. Now, developers were tasked to write code for a single machine, multi-core platforms. Platforms that are capable of doing multiple things at the same time. So this shift from single core platforms to multi-core platforms also necessitates a shift from sequential programming to concurrent programming. Now, what was the initial solution? I'm sure we all know the initial solution was that we just added threads, right? Let's just add threads to the sequential programming model. Easy, right? But unfortunately, it turns out that adding threads to the sequential programming model is not a simple addition. It is, in fact, it is a major disruption. Right? So functions under linear flow of control, they are simple and delightful. But functions and threads, so essentially functions under non-linear flow of control, they are complex and dreadful. So what is the issue? What is the underlying issue? But the underlying issue is that we did not elevate concurrency to a first-class citizen of the programming model. In fact, we just tried to bolt on something to an existing model, hoping that they would seamlessly integrate. It turned out they did not. So then, eventually the ecosystem to improve the developer experience implemented concurrent programming models. So programming models where concurrency is a first-class citizen. And there are multiple examples of that. One is, for example, the actor model. The actor model is a theoretical foundation for languages like Erlang and Elixir. Another one is communicating sequential processes. That is the foundation for languages such as Golang. But there is one model that has been widely adopted across ecosystems and across several major languages, and that is Async Await. So Async Await has become the foundation for languages like TypeScript, JavaScript, Python, Rust, C#, F#, Kotlin, and I'm sure I'm forgetting a few. So it's a very popular programming model. Async Await resembles the developer experience of the sequential programming model to the extent possible. So for the majority of cases with Async Await, the majority of concurrent tasks look sequential. Now, in the 2010s, to the present, to today, we are in the era of exploding complexity. Now developers are tasked to write code for multiple machines. Now developers are tasked to write distributed systems. And this shift, same as before, from single machines to a multi-machine platform, necessitates a shift from concurrent programming to distributed programming. And what do we do? Well, we add networking, right? We add remote procedure calls, we add message passing. Bottom line, we add networking to the concurrent programming model. But just as before, just simply adding threads to the sequential programming model was not just a minor addition. Simply adding networking to the distributed programming model is not, to the concurrent programming model is not a minor addition either. It is a major disruption. So once again, we want to elevate the developer experience of distributed programs. And the answer is distributed programming models. Programming models where distribution is a first-class citizen. And distributed Async Await resembles the developer experience of concurrent programming models to the extent possible. So now for the majority of cases with distributed Async Await, the majority of distributed tasks look concurrent. So this is especially a slide for the students. If anybody wants to take any picture, this is the time. This is a summary of the transition from sequential programming to distributed programming. Sequential programming is characterized by a total execution. Thank you. Sequential programming is characterized by a total execution order and total failure. When we move to concurrent programming, we're adding the partial execution order. We're adding non-determinism. And we are still at the total failure. When we move to distributed programming, we have partial execution order and we have partial failures. Some of your machines may fail. Some of your network messages may be dropped and others still continue. One of the most difficult situations to deal with. So with this framework in mind, we can actually articulate the key requirements that a distributed programming model must address. A distributed programming model must provide coordination for partial orderings, and it must provide mitigation for partial failure. And this is where distributed Async Await comes in. Distributed Async Await extends Async Await and makes distribution a first-class citizen with a delightful developer experience. So distributed Async Await provides coordination and failure mitigation across machines so you can focus on your business logic. Okay, now we said that. Again, you can focus on your business logic. What does that even mean, right? Every single project out there promises you can focus on your business logic, but nobody ever tells you what that actually means. Okay, so for that, let's define two supporting concepts. Let's define semantic signal. Semantic signal refers to the aspects of the code that directly contribute to expressing the solution of your problem. Right? It is necessary and meaningful. It's a necessary and meaningful part of your code that addresses the attention behind the program. And then there is semantic noise. And semantic noise refers to the aspects of the code that do not directly contribute to expressing the solution of the problem that is being solved. It is a necessary but utterly meaningless part of your code that does not address the intention behind the program. Now, when we write, for example, a prototype, then typically what we see is that we have a lot of semantic signal in our code. Most of our code just deals with the problem that we actually want to solve. But then over time, the more production ready our code becomes, the more semantic noise enters the scene. And then if we move forward and we actually push into the area of concurrent and distributed systems, the semantic noise becomes louder and louder, to the point where eventually I cannot even see, when I look at the code, what the application is meant to do. So our goal is to reduce the noise and boost the signal. So we basically want a very high signal to noise ratio so that the code tells its own story. The code tells you what it does. Now let's go over the three programming models in a little bit more detail. So first is a sequential programming model. The sequential programming model is characterized by functions calling other functions in a linear flow of control. And functions compose recursively. And that is a remarkable abstraction. Even our largest systems, the largest systems on this planet, are composed recursively from the smallest building blocks, from functions. Now, when a caller invokes a callee, the caller transfers control flow to the callee and suspends until the callee terminates and transfers the control flow back to the caller. It's a dead simple programming model, leading to a delightful and equally simple developer experience. So that code basically needs no explanation. We are taking one step at a time. The problem here is that there is no opportunity of doing multiple things at once. And concurrent programming models mitigate that issue. Concurrent programming models allow us to express that we want to do multiple things at once. Now, the core abstraction that Async Await adds to functions is the abstraction of promises. Async Await decouples the caller from the callee via a promise. Functions are the universal abstraction for computation, and promises are the universal abstraction for coordination. So a promise, sometimes, depending on what language you're looking at, sometimes they're called futures, sometimes they're called available, sometimes they're called defers, and sometimes they're even called tasks. It's always the same. And a promise is a representation of a future value. A promise is either pending or it's completed. Or if you want to get a little bit more specific, it's either resolved, success, or rejected, failure. So in Async Await, when a caller invokes a callee, when one function calls another function, the caller does not transfer the control flow to the callee. Instead, the caller receives a promise and resumes execution. And the callee starts execution at the same time. Now, eventually, when the caller needs the result of the callee, the caller awaits the promise. And if the promise is still pending, the caller suspends until the callee terminates and completes the promise. And if the promise is already completed, then the caller resumes with the value of the promise right there and then. Now, this is the code that we were looking at before, and it looks very similar. The goal of Async Await was to resemble the sequential programming model as much as possible. However, now we actually have the chance of parallelism. Now we have the chance of doing multiple things at once. And if we wish, we can actually express even more complicated control flow, where we have the possibility to do every single step at the same time. So if you have multi-core machine and enough cores, it can actually happen in parallel. Now, last is the distributed programming model and distributed Async Await. And distributed Async Await extends Async Await with one core abstraction. So far, promises were ephemeral promises. They lived in the process. They lived in the memory of the machine. They were only accessible from this one process, and their lifetime was limited by this process. When the process terminated or crashed, the promise was gone. So now, what we are going to do is we are lifting the promises from the confines of one process and store promises outside of a process. You can say in a database, store promises outside in a process in durable storage. Now, with that, promises become a abstraction for coordination, not only on one machine, but also across machines, across processes. And in order to do that, we give a promise, not only a pointer, but an actual URL. So a promise is a REST resource that is accessible from anywhere, is accessible from multiple processes, and is therefore now a universal abstraction for coordination for distributed systems. And once again, the developer experience of distributed Async Await resembles the developer experience of Async Await as much as possible. Now we can do a short case study. And let's look at how distributed Async Await mitigates partial failure. That's one of my favorites. So let's take super simple. I'm sure all of us have played with AI and large language models at this point. Let's look at a really small example. So locally on my machine, I develop a web application. Could be, for example, Node.js Express, right? And I'm using Ollama and the Ollama API to implement a summarizer. All right, I can send it some text and ask the LLM, give me the summary, a one-sentence summary for that. And then my client is nothing else but curl, right? So I have that on my terminal, local machine, client is curl. So technically this spawns multiple processes, right? Every single one of those is its own terminal. Yeah? So technically this is a distributed application, but doesn't really feel like a distributed application. I'm the only one using it, right? So therefore there's only always one request in the system, and let's be honest, it still all runs on one machine. So while it is a distributed application, it doesn't quite feel like one yet. Okay. But eventually we deploy our application, right? We want to deploy our application, and now we have multiple clients connecting to the web application. Now we are in that territory where it feels a little bit more like a distributed application because I already have multiple clients and therefore I have multiple requests in the system. But on the backend side, it still feels fairly linear. fairly straightforward. The problem, if anybody has ever tried that, the problem with Ollama is or any large language model really, it can be a little bit like resource hungry, right? So this will probably not stay like that for a very long time. So since large language models are computationally demanding, we must spread across machines. So now we have a situation that already does look like a distributed system, and it gives us one more headache. Web applications are usually really simple when a request takes only a few milliseconds, right? Because if anything happens in between, any crash happens, I can simply retry. What's the harm in retrying, right? So I can simply retry, and then instead of 250 milliseconds, I wait 500 milliseconds. If that happens once in a while, that's not too bad. However, something like Ollama, computationally a little bit more expensive, it may take multiple seconds. And it's not only computationally expensive, it is actually expensive. So you may run this, if this is a production application, you may run this on a GPU cluster, you are paying for that time. So if a request enters the system, the client opens a connection to the web application, and the web application opens a connection to the Ollama summarizer. Now here, we actually have a problem, and that problem is a strong dependency that is very common in the Async Await and gRPC world. If the client crashes, it will drop the connection to the web application and to Ollama summarizer. Therefore, wherever Ollama is, maybe 5 seconds into its work, that work will be abandoned, right? For actually no good reason, because the only thing that actually had a problem was the client in the first place. But the connection on the web application and the connection on Ollama will drop. Now, with distributed Async Await and durable promises, promises that have a URL, an identity and integrity, that is unnecessary. If the client drops and the request gets retried, the client simply joins the execution that is already in flight. The web application and Ollama summarizer are non-divisor. And of course, that doesn't only work for the web application, for the client itself. That also works in the middle of the stack. If the client is fine and the Ollama summarizer is fine, but the web application drops, the connection crashes for whatever reason, then once we retry with distributed Async Await, we can again join the computation. And of course, that also works for the Ollama summarizer itself. If that one crashes, that can also be automatically retried. And of course, it doesn't have to be routed to the same machine. It can be routed to different machines. And with distributed Async Await, you get all of that with one line of code. Now, if you're interested in my slides and some references, and of course also the project itself, Resonate is an open source project that has JavaScript and TypeScript SDK and a Golang backend implementation. But for anybody who is interested also in the theory of computation, the theory of threads, the theory of developer experiences, I added some references to this GitHub repository of some of my favorite papers in that regard. And with that, thank you very much. Thanks for being here. And if anybody has any questions, I'm more than happy to answer. Thank you. Please.
Okay, so I don't need a microphone. So my question is, I know there's like a lot of concurrency models. So one critique of Async Await is that it colors the function essentially. So that's like the complaint of many people. So some languages, they switch to, for example, Kotlin and Go. They opt to go with like Go routines, for example. So what do you think of are these differences between, let's say, Async Await and like coroutines in terms of doing it in a distributed way?
So Async Await and Go routines address a concurrency problem, but they do not address a distribution problem, right? So we can look at them and compare them in the sense of concurrency. And there are multiple concurrency models out there, right? Like the actor, like the communicating sequential processes, that is Golang, like Async Await, or also like manually via threads. So when it comes to the concurrency first programming models, actors, CSP, Async Await, I do have the strong opinion that the concurrency first is strictly better than the sequential plus threads. However, there is a fair amount of debate, and one is do not color my function, right? There is a fair amount of debate which one is the better model. I personally enjoy Async Await because it resembles the sequential programming model, whereas actors and Golang, they do not resemble the sequential programming model. They require to rewire your brain, right? So you have to think about programming differently, whereas Async Await explicitly tries for you to be able to think about programming the same way. However, it is still at the end of the day a style question, and it's probably also a question of what problem you are trying to solve. So while I do not have the strongest feeling on the concurrency first programming models, I don't want to say like this one is strictly better than that one. The only thing I want to say is that the concurrency first programming models are strictly better than the sequential programming model plus threads. So, here, the gentleman had a question.
I have a question. Let's say that I have two clients subscribe to the same promise, right? And what happens if the first client has to distribute promise? And what is the behavior of the other client? Does the client receive the data from that promise or it cancel?
That is a fantastic question. I would also like to direct you. We have a specification. We have a durable promise specification so that you can also implement your own durable promise infrastructure if you wish. And the specification addresses that problem specifically. And what we are doing with promises is we guarantee linearizability. So if you have two clients that concurrently, let's say one client tries to resolve a promise where the other client tries to reject the same promise, right? So since it happened concurrently, so independently, we do not know which one is going to win. However, we will guarantee you that everybody sees the same result. A promise, a durable promise, will never lie to you. That is encoded in the standard, and it's also encoded in our Golang backend. In our Golang backend, we employ deterministic simulation testing, and we subject our implementation to basically days of testing condensed into minutes of runtime to make sure that each and every combination is actually tested, and the linearizability is a guarantee that you can rely on. Please.
So usually in tasks which are heavy, you use distributed queues, so you just delegate a task to someone else. But in this case, this is more in the same context. But are there any views, since this is a distributed thing, how much do network latencies and network disruption come into play? Because if I'm doing something else and I want this 1 second addition, the network latency or lag, do you account for those? How do you account for that?
So first, I would very much like if you could visit this my Twitter handle. I was actually tweeting about this morning because I'm still jet lagged and couldn't sleep. So I was tweeting about this morning. There are queues. You are correct. There are queues in the background, but the queues are not a first-class developer abstraction, right? The first-class developer abstraction is application level view is that of an asynchronous function. However, we have in the back end, we have a distributed event loop. And the distributed event loop does use queues and event notifications to distribute work across machines. Now, a very important part, and also one of the papers that I linked in the references, a note on distributed systems, or I'm sorry, a note on distributed computing from 1994. The gentlemen at Sun Microsystems were far ahead of their time. And they argued that we should never try to make a distributed system look like it was not a distributed system. It's a futile effort. One of the reasons is networking behavior and networking latency. That's why for a distributed async await, you actually have to be explicit. You have to be explicit to say, run in the same process right next to me, or run on a different machine. Because we believe that this is not a decision that we can make on a platform level. This is a decision you have to make on an application level, because there are inherent trade-offs in leaving a process boundary that are irreducible. They cannot be abstracted away. So I think you.
First, I want to thank you for your work or your previous work on DevPod.
Oh, thank you.
I also enjoy using it a lot. My question today is, so your model, you have a durable promise that can be distributed on, maybe distributed on machine. So if the async function code from maybe from the client, I have some sensitive information. So how do you guarantee that sensitive information is secure?
Yes. Absolutely, yeah. There is a similar facility, like for example, that you saw in Temporal. So you can use encryption to encrypt the data. But another point is that the model, durable promises, is not a central model. So you can deploy multiple durable promise servers, and you can deploy these promise servers also in private networking, right? So then you can run your computation, your sensitive computation on sensitive data, also in a private network that never leaves the network. Right? So it's not a centralized platform, it is a decentralized platform, and it gives you the opportunity to mix and match. So you can deploy multiple promise servers. Some promises live that have that need wider reach but have less sensitive data, or some promises live in an area that has less reach, for example, confined to the network, but has very sensitive data. Thank you. Yes, please. Oh, sir.
This might be a idea question, but how is this significantly different from the persistent job scaling? Since you are within moving to job system, and it's maybe different from the Async Await.
Yeah, you're absolutely right. Once again, you definitely got to visit my tweet feed. I tweeted about this this morning. You are correct, right? There's like, hey, what is the difference between a job scheduler? The difference is that we don't expose jobs and job scheduling and notifications to the developer as a main abstraction. We are not event-driven, we are imperative, right? We let the event loop translate sequentially looking code onto a job framework. Yes, exactly. You know, a best example is a database. When you say a database has a write-ahead log, right? We are not writing directly to the right. We could, but we are not, right? We do not write to the write-ahead log. Instead, we are using SQL, and SQL is an abstraction on top of the write-ahead log, right? The database writes on top of the or on the write-ahead log on our behalf. That's basically what distributed async await is. It talks to the job framework on our behalf.
I remember last year you shared that you try using web, And also have something maybe more like durable promise that they can suspend continuation, then refine it and
Yes.
send it to another node. So how do you compare that model to your durable and distributed promise?
So in comparison, other platforms, they have a proprietary programming model. For example, other platforms have workflows, and a workflow is a sequence of steps, actions. They have local actions and remote actions. We do not have a proprietary programming model. We have functions and promises that call other functions and other promises. So we try to be as true to the universal programming model of functions and promises as possible. No proprietary programming model on top of that. I'm sorry?
I know from these people that maybe someday they will try to open the Guru under the Piyush cloud.
Okay. Huh?
I'm not sure if they review that.
Oh, interesting though. Any? Oh, we got to wrap it up. Okay. Thank you very much. Thank you very much for being here. Thank you.
Yeah, so we're going to have Zan speaking about OSS decentralized and optimized networking solutions for real-time services.
Okay. Hello, everybody. Yeah. I am a member of eBPF team, and today I'm very happy to be here to interview our last days the open source project with focus on ultra latency, and we are trying to create it in decentralized architecture. Yeah. So the first about me, I am Giang. Yeah, I come from Vietnam, and I have over 10-year experience about networking and media server, and mostly I working on a private closed source. But from 2 years ago, I leave my company and switch to open source project, and we found a group. And if you have interested about open source and about decentralized and streaming, maybe we can join. Yeah. About us, we are the independent team of engineer, and we have a passion about streaming, about decentralized, and also about networking. And currently, we have a 3 member in Vietnam, and some other contributor from some country in the world. So maybe we have a question about why we started that, and the story back from 3 years ago when I create a media server for e-learning edutech solution with students from mostly in Vietnam and Japan, and teacher from US, from Philippines, and also Japan, and maybe everybody will know about the internet connection in Vietnam is not good. In each year we have sometimes the connection is very terrible. So we need to solve the problem with media server because the user from over the world, and we need it supports low latency, high throughput, and multi-zone. Yeah. So we try a lot of solutions. The first is about typical architecture. So everybody will try with it first. We use some centralized server in both Vietnam, US, or Japan, and it not work well because sometimes when connection is bad, maybe we will push the connection closest to server, but when user from multi-zone from multi-country, we don't have any position that good for both. And also we try something like to cascade between the server, but we also have a same problem with the server connections. Maybe some provider is good for US, but another is not. So we don't find any provider with good for every zone in the world. And from that point, we try to another abstract. We trying to overlay the network, overlay to the data between the server. Instead of sending directly from 2 server, we can relay with another hop, and we can implement our smart routing mechanism based on RTT and Zister. And with that testing, we found that with decentralized solution, we can resolve that problem. We also improve the high availability of system because the decentralized architecture don't have any central point. So we can continue to working with any of nodes can be down. So the most strong example is Bitcoin network and something Ethereum network. It can be down. Yeah, cannot be down. So we find another solution on the same decentralized work, but mostly about focus on the permissionless solution and focus on the scalability, not latency. Example, the most popular library will be found in internet, live peer-to-peer and something like that. Maybe when we try to create a multi-zone network with live peer-to-peer, we have the most popular the most problem about the latency is when you have 2 nodes in Asia and Asia, we win to 2 nodes to talk together. But most of the time, we will routing to the US, something like that, and come back to the Asia, and which increase the latency a lot. So with that reason, we trying to create another solution focus on latency and the performance, and with some principle. We will build the custom heuristic by routing, and I will explain it after that. And the data is not directly, we can relay it in a better way, and it can support the both permission and also the permissionless network. And because I don't want it only supports the streaming, it can be applied in another industry, example in IoT, in proxy, and in VPN, something like that. We try to adapt it as a library, as a protocol level to adapt with another industry. So the most important thing and the most the core idea of the network is about routing, right? We have the 3 points of the routing technique. The first, instead of the meaningless node address, we try to embed the address, the location of the node inside the address. With that, we can easy to routing from one side to another node without something like dictionary or something like centralized server to store the location of each node. And with the focus on decentralized network, ignore only the limited view of the network, not all of the network, and ignore instead of calculate the full routing path, we only determine the next hop. Maybe it's been lost packet, but we try to send it fast as possible. So I can explain about the routing technique. It is a very simple idea. It's similar when we have how we travel in the world. So it means us we have a network where it not have a network, a collection of information how to go to every country in the world. Example, everybody in here when we know how to go to US, so first we go to airport. This is the first step. And so we also have every city in my country, in each country, and also ignore when you have information how to go to every place in this city. Yeah, this is a simple idea. An example, when we try travel from US, somewhere in US to Vietnam, Hanoi, and Westlake. So mostly, example, we are in New York, we will go to San Francisco and go to Ho Chi Minh City because we have a direct connection between the US, so direct flight from San Francisco to Ho Chi Minh City. And so we will try to reach Hanoi, and we go to Da Nang City and we go to Hanoi. And because now we in Hanoi, we will know how to go to Westlake. It's a very simple idea, look like the real one. Yeah, when we implement it, we try to minimum the network as a node address for both transfer data will be minimum. We use only 32-bit address, and we split it into 4 layers. The first, the three layer will be used for calculate the locations, and with that, each zone only a very small area, only 30 kilometers square area. And also, because you have a 4 layer and each layer only 1 byte, and it not only hold a routing table with a maximum of around 1,000 entry, and each entry only a sorted array with a maximum size is the number of the connected neighbor. So we can find the next hop with only the big OE one, and it is really fast. And so we only have big OE n. For n is the number of the connected neighbors. So the space will only very small. So because it's not only have a limited view of the network, so we need to update it in each second. And currently, I select it in 1 second. In 1 second, it will broadcast the routing table to all of the neighbor, and the broadcast contain only a little bit of the routing table, the entire routing table. So the send message will only contain the entry that do not go to the neighbor, and also this only select the most fastest pass, not all of the pass, and it allows us to optimize by using something like incremental sync. It will reduce the traffic a lot, but it's not implemented right now. About architecture, we will build it as a structured network, and it not only need to connect a few node, not all of the nodes in the network. to ensure that each layer, example, we have a 4 layers. So back to the example, when we travel in the real world, I only need to know how to go to all of the country and all of the city in my country, all of the plug in this city. And so with that, we don't need to know every address over the world. So we also have a flexible discovery mechanism. We automatically with chalk or Caramlia distribute table. Also, we can have a more and more easier to config. It can be manual by tag. Example is very useful when some private network. Example, when we create stream meta stream server, we usually we have two type of node. It's the gateway and it be a media server node, and it's most of the time the media server nodes only need to connect the gateway node inside the zone, and after that, all of the gateway will connect to each other to provide a full connected network, and so it can done by stack only, not very complex automatic with chalk or Calamlia. So about feature, because it's a network, I focus to create only a very simple feature. So first is key value store, pops up, node aliasing and service routing is the core feature of network, and we only implement that. After that, we will have a service. It's implement more and more difficult or more complex logic, and we have some unique feature which you focus on latency. The first is PubSub feature. I must we have a network. We want to publish the data from the one node to all of the other nodes. Maybe the origin server, something like in CDN one, we call it CDN origin server. Origin server will be sent to all of our nodes, but it will increase the bandwidth of the server, and maybe server will go be down or bandwidth be not enough. But with utmost SDN, we will build something like minimum spanning tree between the publisher and subscriber, and the tree is optimal way. Example, when we send from publisher, it only send to 2-layer relay, and relay when send to next to ensure that it will cover all of the subscriber. And because it not only send to a small set of its neighbor, so it will reduce the network traffic a lot. So next is service feature. So it look like the DNS, but it is like more lightweight. It's a way we implement custom logic. We have only one byte to determine the service ID, and it's very small. It is because I'm focused on private network, and the service list also is seen between the neighbor. And with that, we have a unique feature is that we can route to the fastest node inside that's running the servers. Example is there we have a service 1, and we have a lot of nodes there. Example from node 3, we want to send to service 1. So it have two options. It can be sent to node 2 or node 4, but sometimes the node just 2 and node 4 can go down. And at that point, we can send it to another zone if we have config that. So it's when have more and more scalability and also the higher variability. And we also have some very good feature. We can use to broadcast all of the node that running the service. Example, from node 1, we want to broadcast all of service 1. Maybe something like ping or health check or something like that. We can from node 1 to send to all of nodes that's running the service 1. Then the routing table will take care about how to send it in optimal way. Currently, it is implemented and open in GitHub, and it is only the first version. And we write is entry in Rust for both for performance and safety. About currently, we focus on performance and the testing and easy to testing. So we choose SAN-IO architect, where we decoupling between the logic part, also the runtime, the I/O, everything is that not in protocol path. So we can implement more and more runtime. Example, currently I have only 2 types of runtime, e-pooling and e-pool and KQ. But in the future, I can apply some network accelerator like DPDK, AFXTP, or eBPF for much the routing more and more faster. And we do it in 3 per architect for maximum performance of the service. In the detail, we have some core feature. It is a fixed, and we can implement a service upon the feature. And we have a two-way to talking to customize the logic. We can create the service inside the network, the virus, and embed it inside the node, or you can use external over the message queue, and we can call directly to feature if you don't want to build a service, or you can build a service. For testing the performance, also the optimizations, we create a network with 31 nodes in 4 zones over the world. So as you can see here, and we use VPN feature of the network, and we use ping, the very popular tool, ping, to test latency between the nodes with both direct connection over VPN. And I found us a very interesting result. We can optimize a lot of connection. Example, in there we have a collect a 10 optimizer way. Example, from Sydney to Viettel in Vietnam, the public connection, you have a latency about over 200 milliseconds, but over the network it reduce about 100 milliseconds. Is about 42%. It's very a huge improvement for something like streaming server or IoT system. We have some use case. The first is a reverse proxy for smartphone. Is we collaborate with Lumi Home in Vietnam to use a reverse proxy for IoT system, and found that it can optimize 7 times latency. It can down from 1 second to something like 100 milliseconds, and also reduce the maintenance cost, because decentralized network can be go down any node without interrupt all of the node network, and also reduce the infrastructure cost. We can don't need something as centralized centralized server or centralized expensive networking accelerator. And also he can use some home device as a relay. Some example, when we have a lot of node in the network, maybe some private node can be used as a relay only, and it's a public in that GitHub. And if you have interest, we can discuss more. We have another use case, decentralized streaming server. It's the most focused, but currently I focus on both. I made that it's different from other sources, that streaming server is working something like a centralized, but we're trying to create it decentralized. It's something work like Cloudflare, called it public some day ago, and it's a huge multi-zone media server where user can connect to any of closest nodes, and network will do the own of the work, and a room can be run in the multi-zone, and we can have an unlimited number of users. And currently we support mostly RTC, RTMP, and SIP, but the protocol will be extended. And it only be used by some customer in Vietnam and in Japan. Like it's only an idea, not finished right now. We try to reuse the routing technique to create a network between the user by working like PubSub, but we try to create this minimum spanning tree from the publisher user to another user. And it from internet and from my experience, we have also a peer-to-peer connection successfully about 70%. So if we have a network with a lot of users, so we can broadcast from one user to another user without the relay to any server. So it will reduce the cost of server or loss, and also the scalability, the number of the user without the take a lot of cost about infrastructure. Yeah, currently I have a demonstration when we try to integration in streaming server. Yeah, we have a network with some node over the world. Currently, it have only two zones, Hong Kong and Vietnam, and we have a conference between the three people, and each people will connect to out of the different server, and the network will take care about how to server will talk together to create a networking, and you can see the ping gray so the state of the connections, and when a connection is interrupt, the routing technique will take care to find another optimal way as for don't interrupt the conference. Yeah. Yeah, thank you very much. It's very, very fast software. If you have any questions.
Any questions?
Thank you. I think it's a great improvement. And I have a question about, you said that it's decrease the maintenance cost, but I'm not actually understand why it's decrease that, because I think basically previously we have a centric server and we have to maintain that. And this time we have multiple sub node. I mean, in the smart home use case, you said that is less maintenance cost, but I think it's more place to maintain, isn't it? I'm understand wrong or something. Please correct me. Thank you.
Thank you very much. Yeah, about the maintenance cost, maybe we will have a more and more server, but the server is working like serverless, so we can it can be go down, and if any server go down, we can start it in another zone without any configuration on, and actually it don't have any kind of database, any kind of persistent data, so if we have auto scale in multi-zone, it will work automatically without any manual by hand. Yeah. The key point here is server is simple. It only the forward, not do something like complex logic. For some server go down, it don't affect any effect to other node. This is the main idea.
Any more questions? Okay, thank you.
to do? Yeah, if you want, you can still come in. Like we saw it. It's fine. Just find the topic. Suvin, should I just say Suvin? Comfortable.
Hi everyone. So we have a talk by Suvin on rethinking cloud native security with zero trust.
Yeah, you can go.
Good afternoon, everyone. Hi, good afternoon. Hi. Okay, so once again, good afternoon to all of you, and good day for all of you joining us online. And today we are going to talk a bit about rethinking cloud native security with zero trust. Now, usually when I speak a lot of words per minute. So if this is like too fast for you, please let me know. I'll slow down. Okay. And before we start, can you know like how many university students we have? Raise of hands. University students? Not? Okay, we have a couple of them. Awesome. Okay, so let's start. Now, my name is Suvin, and I'm a software engineer at WSO2, and I'm working on the identity and access management team at WSO2. That's my email if you want to ask me any questions or for clarifications after the session. Now today, I'll start with a brief introduction to DevOps and cloud, and then we'll walk you through the traditional perimeter-based security model, and then our main highlight of the talk, zero trust, followed by how it works and different implementation strategies, and finally limitations and adoption. And then you'll have your time to take the mic and ask me questions. All good? Awesome. So let's start with a little introduction to DevOps and cloud. We'll start off with the significance of cloud environment in today's. Now, in today's world, businesses are increasingly relying on all these cloud methods or cloud computing to stay competitive and agile. Now, moving on to cloud computing, organizations can have many benefits. You know those already, right? Scalability, flexibility, cost efficiency. And the nicest thing about this is you don't have to have your own infrastructure. You can provision them as you go on the cloud, whenever you need, however you need. As a result of this whole cloud transformation, businesses can innovate faster. They can deliver services more efficiently. They can reach global markets very easily, and so and so. Now, talking about DevOps a bit. Now, DevOps is what actually enables organizations to achieve the goals I said earlier and to be able to deliver products in high velocity. Now, of course, in your enterprises, better DevOps, that means faster time to market. You can ship your products very fast, and it will improve your product quality. And of course, better customer satisfaction. The happier the customer is, the more businesses you gain, and so on. Now, with this whole transformation of cloud and DevOps scene, the threat landscape goes as well. When the organization is increasingly using these DevOps and cloud services, the threats against these cloud services also increases. Cyber attackers, they keep constantly trying to hack and do other sorts of malicious actors for these cloud services, and they often causes huge disruptions to your organization. Now, these modern concepts we have these days about hybrid cloud, multi-tenancy, and all these complex methodologies, they also increases complex security risks, which we should very carefully address, or else our business will be going into disruptions. To talk more about some statistics about the cloud landscape, you can see in the last year, in the US alone, there were more than 2,000 cyber attacks happen. And not to mention the Johnson's control faced incidents, and the Cloudflare mitigated a 0-day vulnerability. So all these attacks, most of these attacks happen in the cloud space. Now you can see how serious these disruptions were. Right. Now that's about cloud and DevOps in brief. Now let's talk about the traditional security model we've been following so far. We call this as the perimeter-based security model. Now, as the diagram you can see, we have two services in this enterprise, inventory and billing, and both of these services are protected by a boundary. Now, if you are staying outside of that boundary, external traffic, that goes to the firewall, and the firewall will make sure that this is a legit request and validate it, and after that, it will pass it to the relevant service. Now, the limitation with this perimeter-based security model is that there's a single point of failure, which is the firewall. So you can see the firewall is the only thing between your trusted and untrusted network. And if the firewall fails, all your internal traffics, internal services will be exposed and it will be vulnerable. And the other one is insider threats. Now, in this perimeter-based security model, you are trusting all the things, all the network requests coming from the inside, and you are not trusting anything from the outside. So if there are malicious actors intentionally or unintentionally within your network, your network will be not secured. Even a compromised set of credentials can make your system vulnerable to outsider attacks. Those are the limitations of this security model. As a solution, we have zero trust architecture. Trust, but verify. Now, let me briefly walk you through around the concepts of zero trust. Now, like I said, zero trust is basically based on the principle of never trust, always verify. So with this model, we always assume that threats can originate either from inside or maybe outside. Malicious actors or harmful attempts can occur in both sides. So therefore, zero trust advocates you to verify identity continuously and all that verify requests coming from different devices continuously, and do all these validations and verifications regardless of the location. By doing so, zero trust shifts our existing security paradigm from a network-centric one to a data-centric one, because zero trust advocates you to protect our data regardless of what your origin is, right? Then zero trust, this whole architecture is based on a couple of principles. Now, if you Google these principles of zero trust, you may come across very, very different kind of interpretations, but this is the one I usually follow. So from all of these concepts, these principles are the most prominent stuff. Assume breach, continuous monitoring, and risk assessment, verify every access request, and so on. We'll discuss them in detail now. Okay, so we'll start with assume breach. Now, assume breach is a pessimistic approach where you always assume an attack will happen instead of attack might happen. So you always think, okay, so there will be a cyber attack or something instead of expecting one to happen. Now, this principle, always expecting a breach, will transition your defense strategies into a more active network than a passive defense strategy, because you're proactively taking measures to eliminate attacks instead of doing something after an incident happens. Now, with that, when you assume breach, you need to monitor your network constantly and verify all the access requests that comes through your network. So like I said earlier, regardless of the origin, whether it is inside net origin or outside, you have to verify this and keep monitoring. Now this verifying includes verifying identity of users, the devices they're accessing from, and different kinds of applications before accessing any of the resources in your enterprise. Now, multi-factor authentication can be a very crucial part in this thing, because when you combine multi-factor authentication with risk-based prompt, it will give you even more secure way to authenticate your users. And by constantly monitoring your traffic and user behavior and system logs and all these observability related stuff, organizations can detect an attack before it happens mostly, and then take proactive measures to mitigate the attack. Now, the least privilege principle is another principle of zero trust. And what this means is giving the users only the necessary privileges they want. For an example, let's say I need to perform some kind of a reduction on some service. So for me to perform that action, I only need the read access. So I should only get the read access, not write access, not edit, not delete, or anything. Now, by limiting these user privileges and access rights, the organizations can always reduce the risks of internal threats mostly, because I only have permission to do what exactly I want to do, nothing more else. Right. Then microsegmentation. Now, as the diagram says, it's a bit of self-explanatory. So what this principle does is it divides and groups your services in the organization into different segments. Now you can see in this example I took, segment 1 has 2 services and segment 2 has another 3 services. And all of these segments are protected by the enterprise boundary with a firewall. Now, this grouping, you can do this grouping based on your business requirement. These are a couple of examples. You can group them by workload characteristics, the type of work they do, and sensitivity levels, and trust boundaries, and the list goes so on. Now, each of these segments are protected by their own access controls and firewalls, so that even if one segment gets breached, the other segments will not have any effect of that. This is something like an isolation of the threat. I'll explain you how we can implement this one a little bit later on. Right. So those are the principles of zero trust and what zero trust means in very brief examples. So to recap the things I said so far, zero trust is a principle that advocates you to trust everything. Sorry, not to trust everything, but verify all this stuff. You guys are good. And I have discussed a couple of principles of zero trust. Can you guys name a few? Microsegmentation, monitor, sorry? Assume breach, yes. Least privilege, of course. Yes, multi-factor authentication. Okay, awesome. Now, these are very conceptual stuff. So let's see how you can implement these zero trust principles in your organizations. To do that, we are using something called a cell-based architecture. Now, this architecture is a decentralized referent architecture made for cloud-native applications. Now, with the cell-based architecture, this is how you can implement zero trust. So, like any other enterprises, you have the enterprise boundary. That's the limit, outer limit of your organization. And inside this enterprise boundary, you have different cells. So by the first look of it, can you see a principle of zero trust in this diagram? The last one we talked. the services are grouped in the cell-based architecture. That's microsegmentation. Yes. So when you microsegment in cell-based architecture, we call this segment as a cell. Now in this diagram, we have two cells, and cell 1 has 2 services and cell 2 has another 2 services. And each of these cells, they have their own firewalls and access control stuff. On the top of that cell, we have something called the cell gateway. And the cell gateway is responsible of doing those access control, verifying identities and doing all this stuff. And on the enterprise boundary for the external traffic, we have an external gateway, something like a firewall. So an external request will first come to that point, and after sanitizing it, it will come to the internal network. Now I'll explain how the network traffic flows through this whole thing. Okay, so let's assume in this diagram, let's assume service 1 wants to talk to service 2 in the cell 1. First, service 1 of the cell 1 will talk to the cell gateway of cell 1. And cell 1 will make sure that this request is actually coming from the service 1, and it will do access control rules, validating scopes, and anything that your business needs to do. Then the gateway will forward the request into the destination, which is service 2. Now, service 2 knows that this request is an authentic request and the gateway has validated it, and it will perform the business logic and do the calculations and do anything, and it will return the response back to the gateway. Now, the gateway knows this response came from service 2, and it will forward that request into service 1. So the cell gateway verified the request for both ways. Now, what would happen if I want to talk to service 1 of cell 2 from cell 1? So first, service 1 of the cell 1 will talk to its gateway, cell 1's cell gateway. It will talk to the cell gateway of cell 2, and then the cell gateway of cell 2 will talk to service 1 of the cell 2, do the operation, get the response, and follow the same path. Now you can see both of these cells have their own kind of gateways and their validation logics. So your request will be validated multiple times before reaching the actual endpoint. So what's going to happen to the outside network traffic? It goes something like this. So we have an external source outside of our enterprise boundary. And on the enterprise boundary, we have an external gateway. Now, this external gateway has all these sanitization logic and validations to do and validate outside traffic. So it will first hit the external gateway. So the external gateway will perform the validations, and then it will know the destination of the request, and it will forward that to the cell gateway of that service in that service. Now the cell gateway will again validate and do all this stuff, and then it will forward the request into the relevant service. After it reaches the exact service, it will again perform all these operations and will send you back the response in the same way. That's how the zero trust can be implemented using the cell-based architecture. Okay, now that you know what zero trust is and how you can simply implement and design an architecture, how you can implement zero trust in your organizations. Can you guys have any ideas? I mean, it can be anything, just, I mean, a good start. Yes, we can do that. We can have a gateway and do this identity-based stuff. Yes. So I'll tell because we don't have much time. So you have two main methods to do this. if you are an existing company with some sort of enterprise architecture, you can migrate your existing components one by one into this new zero trust architecture. When you're doing this, you need to design the new architecture based on zero trust, and then do a feasibility assessment and do your inventory and make sure this is something your organization can actually do. So you're actually feasible of. Then you have to migrate your components, the legacy components, one by one. It can be IAM stuff, network segmentation and microsegmentation, and so on and so forth. And most importantly, you need to make sure that your organization is compliant with standards and you have proper governance framework over all your design architecture. That's the first stage. Or else, if you are new to these enterprises, you can use a platform as a service which has zero trust built in already, so that you don't have to do it yourself. Instead, you are simply buying a subscription or something to an existing service that has zero trust built in. This way, you don't have to do any of these. You can just add developers instead of building platforms. So these are the two methods that you can implement zero trust in your organizations. Now, talking about adoption and challenges with zero trust, there are a couple of limitations and challenges with this approach. It can be complex because in this example, I took a very basic scenario, but when you're actually dealing with your enterprises and business stuff, the use cases can be quite complex. And then maintaining good user experience might be difficult for you because these constant validations and prompts might affect user experience. So then you have to think twice, and make sure that this is something that doesn't break your user experience. Then, of course, legacy systems and applications are a bit difficult to migrate, and organizations usually keep them as it is because they are stable systems. And skill gaps of the developers. Before moving on to any of these concepts, you need to make sure your developers are well educated about it and knows about these concepts very deeply. About the adoption, in 2022, there was a presidential order from the US encouraging organizations to use zero trust, and followed by that, the US Department of Defense issued a white paper on zero trust, encouraging organizations and to introduce some kind of sample implementation strategies that they can use to implement zero trust in their organizations. Yeah, that's it from me about zero trust. And if you have any questions, I'm very happy to answer.
So when you show the cell-based architecture, right? What sort of proxies or tech are you using? Is it like a service mesh? Is it something related to that?
Yeah, that's a great question. So the implementation is actually up to your organization and for your business requirements. So if you want to use a proxy, you can do it in your gateway. And if you want to use some kind of service mesh stuff, you can use that service mesh capabilities to do observability, to monitor all the requests and track them. So yeah, it's once again, it's up to your organization to decide what technologies you are putting in. This is something like the conceptual thing that you have to do this and do the architecture. Any other questions? Okay, seems none. And these are a couple. Okay.
When you show me about the cell-based architecture, can you show me about the difference between cell-based architecture and microservice? And why you apply cell-based architecture and zero trust instead of microservice and zero trust?
I'm sorry, I don't follow. Can you repeat the question?
Microservice.
Microservice?
Yeah.
Okay.
Yeah.
Can you repeat the question?
Can you show me the difference between the cell-based architecture and microservice? Yeah. Yeah.
Okay, thanks for the question. So he's asking about difference between a microservice and the cell-based architecture. So in the cell-based architecture, you're actually grouping up microservices. So these are microservices. And in the cell-based architecture, what you're doing is you are considering some similarities between these microservices, and then you are grouping them together. I hope that answers your question. Okay. Yes.
So I want to ask that. So normally we will have like a central identity providers in the system, right? And I want to ask that if this cell gateway is the same as an individual centralized central identity provider, or it is like separated from the system. So the gateway have to call that identity provider again just to verify the request is like authenticated or not.
Yes, actually, that's a very good question. So when you are looking into this diagram, you can see these the cell gateways. The functionalities are a little bit redundant, right? So this is because this one is a very conceptual thing. In your actual implementation, there can be one central identity provider, and then you can forward all the requests to that same thing and do the validations and authorizations and authentications. So it's like it's up to your organization to actually decide if you are using decentralized identity provider or anything. So like you said, we can use a central identity provider as well. And again, it will depend on your organization's capability and cost effectiveness and things like that. Yeah.
I mean that it is like required for every request to end up at decentralized. So basically,
Okay.
Or it is like, or it can be authenticated inside the cell gateway. So what
Yeah.
for every request,
Uh-huh.
you will have connection authentication for that request. That adds more latency, that adds more request time.
Yeah, that's what I said. If you want to do that, you can do it here. Authenticate all the requests, or you can simply trust some of these requests and skip that authorization part and save that latency. Actually, I'll show you. Yes.
Each request or each workload. For example, each service has an identity. So for example, service 1 is an identity that you trust. It's like a size.
Yes.
Yeah. You can use something like HTML, which has but there are different ways to do it. Okay, so it's not like prescriptions. Yeah. It's just one kind of architecture. So you can also remove the micro segmentation and you can just use that.
Yes. Okay. I think I can show you an example for that. So this is something like you asked, right? So in this architecture, you are trusting all this network traffic between in this cell, within this cell. So you are not authenticating it once again. So if you want to communicate from here to here, you can go to the common gateway and then get it authorized. Yeah. This is another way of doing this implementation. The one I showed you was like a pure conceptual thing. Any more questions?
Any more questions? Or you can chat with them outside.
Yes, of course. Okay. Thank you so much, folks, for listening. And
no, we got two, only one. Yeah.
Say his name. No, 3 p.m.
I'm going to meet.
Speaking about securing container images with Wolfi.
Xin chào mọi người. Bài talk hôm nay sẽ về Secure Container Image sử dụng hệ điều hành Wolfi. Mình là Tuan Anh, đang lead team Tech Platform ở VPBank. Ok, thì, đầu tiên mình sẽ nói một chút qua về cái context. Mình muốn check qua một chút trước là mọi người ở đây đã sử dụng container bao giờ chưa nhỉ? Ok, thì mọi người hiểu container là gì đúng không? Container nó là một cái concept rất là đơn giản, sử dụng tất cả cái tính năng của kernel. Đó là C group và namespace. Namespace giúp cho chúng ta access những cái gì, resource nào đúng không? C group access với resource với cái limitation như thế nào? Ok, thì container sử dụng các cái công nghệ đó để isolate cái application của mình. Thế thì context ở đây của team mình là mình run một cái tech platform team, mình support tất cả những đội phát triển development team, đúng không? Và họ có nhu cầu là đóng gói tất cả các phần mềm họ phát triển vào trong container image. Ok, thì bài toán ở đây đặt ra là gì? Mỗi team họ lại bắt đầu sử dụng một cái base image riêng. Base image đấy có thể bắt đầu từ một cái traditional OS như là Ubuntu, như là Debian, hoặc là sử dụng một cái official image trên Docker Hub như kiểu Python, Node.js mà team Docker họ sử dụng, họ đóng gói lại. Thì mỗi team nó là một cái base image như thế, và họ rất là có vấn đề là mỗi khi có vulnerability họ lại phải fix, đúng không? Bây giờ mình muốn giải quyết cái vấn đề đấy once and for tất cả các cái đội development, tức là họ không cần phải quan tâm họ sử dụng base image như nào nữa. Technology platform team sẽ maintain, build và maintain các cái base image đấy, đảm bảo zero vulnerability ra cho họ, và họ chỉ quan tâm đến ứng dụng của họ bên trên và tất cả những cái dependency mà họ sử dụng mà thôi. Cái image này should be là easy to extend. Trong trường hợp mà mỗi đội này có một nhu cầu gì đó đặc biệt riêng thì việc extending các cái image này nó phải dễ dàng, nó không quá khó khăn đối với họ. Nó cũng phải là rất là low maintenance, chủ yếu là mình không muốn ôm tất cả những việc mà maintaining các cái secure base image này vào team của mình chẳng hạn. Nó should be là low maintenance và should mostly be autopilot, hoạt động một cách tự động 100%. Và sẽ get out of developer way. Developer không hề phải quan tâm đến base image là gì nữa, không hề phải quan tâm đến fix vulnerability của base image nữa. Thì đây là cái context mà vấn đề mình đang có và mình sẽ giải quyết cái vấn đề đấy như thế nào với Wolfi. Ok, thì back lại cái vấn đề về base image, mình có những option gì? Option đầu tiên là mọi người sẽ sử dụng một cái traditional OS. Mọi người sẽ viết Docker bằng một cái như kiểu là from Debian, from Ubuntu. Đây là những cái traditional OS. Mọi người optimize lại, cắt bớt các những thành phần không cần đi để build cho cái container image. Giải pháp thứ hai là sử dụng các cái runtime image, official image từ Docker Hub. Ví như là from Node.js, from Ubuntu. Đây là những image mà Docker đã build sẵn cho họ. Cũng là base trong traditional OS thôi. Một trong giải pháp thứ ba mà invent bởi Google đó là giải pháp Google Decentralized. Decentralized là một cái container image build bởi Google. Họ vẫn base trên một cái traditional OS thôi, nhưng họ sử dụng Bayesian build vào với cái concept của họ là gì? Minimum attack surface. Ứng dụng của bạn, runtime của bạn cần những cái gì thì họ sẽ cho những cái đó vào trong container image thôi. Ngoài ra những gì không cần bỏ hết ra. Thì đó là concept của Decentralized. Hoặc là một số giải pháp khác họ build một cái container optimized OS riêng. Ví dụ như là trên GAT họ build Wolfi như trong bài hôm nay, hoặc là Red Hat họ build một cái OS container optimized OS riêng này của họ. Thì mình sẽ đi qua từng option này, mình sẽ phân tích pros and cons của từng giải pháp và tại sao lại mình lại cuối cùng lại chọn giải pháp với Wolfi. Ok, thì mọi người sẽ đặt ra một câu hỏi này: tại sao lại build đi một cái OS mới làm gì? Nghe nó phức tạp quá đúng không? Tại sao chúng ta không leverage những cái existing traditional OS? Cái traditional OS nó build ra với một mục đích riêng. Mình có các cái traditional OS như Ubuntu, Debian, Arch Linux từ lâu rồi. Họ build cho mục đích gì? Cho server, cho desktop OS. Họ không bao giờ, họ chưa có cái khái niệm về container cho đến những năm 2003, 2004. Lúc đấy cái concept về container mới bắt đầu nổi lên, đúng không? Đấy, họ design cho desktop và server usage. Có rất nhiều tool mà không cần thiết dành cho container workload nhưng mà vẫn được embedded vào. Họ có cái lịch release cadence riêng. Ví dụ như kiểu bạn có một cái image về Nginx build on top of Debian, thì team Nginx sẽ maintain image đây chẳng hạn, đúng không? Nhưng mà Debian OS nó có một cái vulnerability gì đó, Nginx không quan tâm mà, không, tôi có lịch release của tôi, phiên bản của tôi đang là 1.0 đúng không? Tôi sẽ chờ đến 1.1 tôi sẽ include cái bản fix ấy vào. Còn hiện tại tôi cứ lo tập trung release theo đúng cái lịch của tôi. Giả sử như kiểu họ có lịch release 3 tháng một lần. Vậy thì trong 3 tháng này chúng ta sẽ chạy với lỗ hổng đấy à? Không nên như thế đúng không? Mình không muốn như thế. Cái đó là cái mình muốn fix. Với cái approach thứ hai của Google thì approach này là một cái rất tốt. Và mình cũng recommend là các bạn dùng Google Decentralized nếu mà nó work cho các cái use case của bạn. Ví dụ như một số use case của bạn là bạn build app của bạn trên Golang hoặc Rust, nó hoàn toàn có thể self contain được. Và Google Decentralized nó đáp ứng được nhu cầu của bạn. Bạn không có nhu cầu extend thì quá nhiều. Nếu Google Decentralized work, dùng nó. Thế thì tại sao nó lại có cái giải pháp của Wolfi sinh ra? Wolfi nó lấy cái concept của mỗi các cái OS kia một chút. Mình sẽ phân tích từng điểm một chút. Nó gần giống như Decentralized. Có một cái fun fact về Wolfi, đó là cái team mà build Wolfi này cũng chính là team ở Google build ra sản phẩm Decentralized. Thì nó giống như Decentralized nhưng nó base trên một cái rolling release distro, giống như kiểu Arch Linux hơn là giống kiểu Ubuntu. Ubuntu mình sẽ có lịch release hàng năm đúng không? Từng release. Còn Arch Linux là khi nào bạn có và cái mới là sẽ rolling release đều ra, và tốc độ release sẽ nhanh hơn rất nhiều. Nó gần giống như Alpine. Các cái ecosystem của nó build xung quanh gần giống như Alpine, nhưng nó có điểm khác biệt là cái libc implementation của nó không dùng MUSL mà nó dùng glibc. Cái này là một điểm rất quan trọng, là bởi vì đa phần các cái software mà mình chạy based on glibc. Thế nên là compatibility của nó nếu mà mình sử dụng glibc sẽ tốt hơn rất nhiều. Nó khác với Decentralized một chút nữa là nó sử dụng YAML thay vì Bayesian build base system của Google. Thì ở trong Google họ có một cái build system nó rất là đặc biệt của họ, đúng không? Và cái base build này là một base trên cái đấy, nó dựa trên cái nhu cầu của Google, nó hơi specific và rất là khó dùng, nó rất powerful nhưng rất khó extend. Lý do Wolfi không sử dụng cái base build tiếp tục này là bởi vì nó khó extend với người dùng hơn. Bạn muốn add thêm một package nó rất là phức tạp. Thì đấy là cái concept mà tại sao cái team Wolfi lại đưa ra quyết định là build. Tức là họ lấy cái idea của Decentralized, nhưng instead of basing on a traditional web like Debian, họ chọn một cái rolling release. Họ lấy các concept gần giống như NPy, nhưng thay vì libc dùng MUSL, họ dùng glibc. Ok, về cái option thứ hai, giả sử như mình chọn một cái official image runtime như kiểu là Node.js như Python, đúng không? Size của các image này nó base dựa trên cái base image mà các bạn chọn, đúng không? Thường là mọi người sẽ chọn Debian. Thường là nó không reproducible. Tất cả cái base image này Docker Hub đều sử dụng Docker file. Mọi người biết cái vấn đề với Docker file là khi mình chạy run một cái command gì đấy là gần như reproducibility của nó mất hết, đúng không? Khi mình nói đến reproducibility của nó, tức là mình nói bạn build cái image tại thời điểm này và bạn build image tại thời điểm này, một năm sau nó phải giống hệt nhau. Giống hệt nhau không phải là chỉ theo kiểu là về tính năng nó giống hệt nhau, mà nó phải là bit by bit giống hệt nhau. Binary 010 thì cái một năm sau mình build vẫn là 010, giống hệt. Cái sum của nó phải giống hệt nhau. Đó là về reproducibility. Nhưng mà các cái image này họ có release cadence riêng của họ, đúng không? Cái priority lớn nhất của team Docker khi họ maintain cái image này, họ không có cái lịch release giống hệt như cái kia. Ví dụ giả sử như có vụ XZ vừa rồi, giả sử nó được bundle vào, lần release tiếp theo chúng tôi sẽ fix đến, chúng tôi không biết nó là bao giờ. Với một traditional OS ví dụ nha, giả sử một cái package được fix, đầu tiên sẽ là upstream của các cái package đấy được fix. Sau khi các cái upstream đấy nó fix xong thì các OS bắt đầu đóng gói các cái bản release đấy vào OS của họ, đúng không? Và thường nó sẽ đi vào các cái stream như kiểu testing stream trước, sau đó rồi mới đến stable stream. Vì thời gian như thế, từ một cái package được fix cho đến khi nó được release vào trong cái OS có khi tính đến bằng năm. Thì nó có release cadence riêng này, nó có rất nhiều lỗ hổng bảo mật và có rất là limited SBOM support. Nhưng một có điểm là nó rất dễ sử dụng, bởi vì là trong các workflow của mình họ đều release dưới dạng là Docker Container Image, tức là rất friendly, mọi người đều biết viết Docker file như nào, biết dùng Docker file như nào rồi, đúng không? Thế đấy, nó có rất nhiều cons nhưng mà cũng có một cái pros là mọi người đã biết cách sử dụng đấy rồi. Một cái nữa, như mình nói phía trước, Google Decentralized nó work cho một số use case nhất định. Nếu bạn không cần phải extend quá nhiều, nhu cầu của bạn nó chỉ đến thế thôi, bạn không cần add quá nhiều quá package, bạn không cần phải custom lại cái Decentralized đi nhiều quá. Nếu nó work cho bạn, good, dùng cái đó. Nó based trên một cái traditional OS, tức là nó vẫn gặp cái vấn đề về release cadence, đúng không? Nó based on Debian. Thì khi nào Debian fix họ mới fix, họ không tự fix được. Đấy là vấn đề của Decentralized. Và một cái vấn đề lớn nhất đó là họ sử dụng Bazen build. Đấy, có rất nhiều issue trong cái repo của Decentralized nói về việc là giả sử tôi muốn cài thêm một package A thì tôi làm thế nào? Thì gần như maintainer của Decentralized không có câu trả lời official về vấn đề này. Cách họ recommend là gì? Bạn list ra toàn bộ package đấy và dependency của nó. Trong một số trường hợp nó phức tạp, dependency như kiểu package A phụ thuộc vào B, B phụ thuộc vào C, C phụ thuộc vào D. Bạn tự generate cái chuỗi dependency đấy ra và bạn include vào image của bạn. Đấy là cách của họ recommend. Ok, nếu mà mình phải customize như thế thì Decentralized sẽ rất là khó dùng. Thế thì mình tự build container image của mình được không? Câu trả lời là được. Build container image thực ra rất là dễ. Nếu bạn build from scratch, mình không nói với các bạn là sử dụng Docker file trong build container image nào. Nếu bạn dùng bash, bạn viết container image cũng được. Lắp ghép các cái này khá là dễ dàng. Nó chỉ khoảng vài trăm dòng script thôi. Và nó khá là dễ dàng. Ok, thế thì quay lại cái vấn đề. Thế một cái idea container image nó sẽ như thế nào? Như kiểu giả sử như mình có mong muốn trong một cái thế giới perfect nó sẽ trông như thế nào? Cái mình muốn nó sẽ là gì? Minimum. Mình muốn take cái concept của Decentralized của Google. Nó là minimum attack surface. Bạn dùng cái nào thì bạn include cái đấy vào. Cái nào bạn không dùng, bạn bỏ nó ra. Thì vulnerability của nó bạn sẽ không phải fix, đúng không? Như kiểu chẳng hạn image của tôi là Aginic, bạn cài thêm apt các thứ vào làm gì, đúng không? Package Manager vào để làm gì? Tôi đâu cần. Bạn cài thêm shell vào làm gì đúng không? Tôi đâu cần shell đâu đúng không? Runtime của tôi không phải cần cái đấy. Thì nó mang cái concept minimum attack surface của Decentralized, đúng không? Mình muốn nó phải có hai lý do. Một, giảm vulnerability. Hai, giảm size của image. Cái mình mong muốn tiếp theo đó là nó easy to extend. Đây là cố gắng để fix cái vấn đề của Decentralized. Tức là mình sẽ có các cái base, nhưng nếu các team có nhu cầu, team development có nhu cầu add thêm các dependency vào, extend thêm từ các cái base image của mình ra, nó phải dễ dàng nhất có thể. Nó phải reproducible. Đây là một vấn đề của security nữa. Reproducible như mình nói vừa rồi. Bạn build ngày hôm nay và vẫn build 1 năm sau, nó phải ra giống hệt nhau. Xong nó phải hoàn toàn giống hệt nhau 100%. Nó phải có S-bomb, tức là nó phải cung cấp được là bên trong nó bao gồm những cái gì. Tôi sẽ build lại nó như thế nào. Trust đúng không? Bạn đưa cho tôi một cái image, bạn bảo là nó bao gồm ABC. Và cách build lại như thế nào. Và nếu tôi làm theo như thế, tôi phải build được một cái giống hệt như cái bạn đưa cho tôi. Thì đó phải có S-bomb và attestation nó sẽ available. Attestation là cái mình build như thế nào, dùng như thế nào để build ra nó. Ok, thì đây là cái goal của mình. Mình mong muốn những cái như thế này khi build những cái set container image của mình. Thì ok, đây là Wolfi. Đây là một cái minimum image của Wolfi. Nó sẽ trông như thế nào? Nhìn qua sẽ rất đơn giản. Nó sẽ có một repository. Bạn cài package đấy từ đâu? Keyring của nó là gì? Để verify signature của cái image của các package đấy. Bạn cài những package gì vào? Ở đây mình cài một cái ví dụ rất đơn giản là một cái base layout, nó cài sẵn ra tạo bằng các thư mục cơ bản structure của một cái image, của một cái OS thôi, không có gì cả. Và cái entry point của nó là cái gì? Và environment của nó biến gì? Đây là một cái khá là minimum. Thì nó chính là nó declarative, bạn viết bằng YAML. Nó reproducible, bạn có thể build lại cái này, bạn lock các cái package vào đúng version, bạn có thể build lại. Hôm nay, 1 năm sau, nó ra giống hệt như thế. Nó sẽ có S-bomb và attestation included. Sở dĩ mọi người chú ý một chút là S-bomb nó không giống hệt nhau. Với những cái traditional OS bình thường nhé, khi bạn có một cái image Ubuntu Debian thì cái cách họ generate S-bomb là họ chui vào trong đó, họ xem bên trong nó có cái gì và họ đoán là nó có cái đấy, version bao nhiêu. Cái S-bomb quality nào họ đến từ sau khi họ làm xong là một team khác, đúng không? Với Wolfi họ build everything from source và họ generate S-bomb. Bởi vì họ build thế nào nên họ biết nó bao gồm những component gì. Thì S-bomb quality cái mà bill of material của mình nó sẽ là cụ thể nhất có thể, rõ ràng nhất bởi vì họ build from source mà. Mình sẽ đạt được cái yếu tố zero hoặc là low CV cao. Most image build with Wolfi đều đạt cái vulnerability cao là gần như là bằng không, đa phần các trường hợp. Và nó work well with Dockerify workflow bởi vì là mình vẫn deliver Wolfi này, vẫn build ra các container OCI container image như bình thường và mình vẫn gắn nó vào các cái workflow bình thường của mình như bình thường. Thế nếu bạn muốn extend cái Wolfi này ra thì bạn sẽ làm thế nào? Bạn sẽ viết một cái YAML again. Mình sẽ define một cái package mới tên là hello, đúng không? Để build nó mình cần cái gì? Mình cần fetch suộc từ đâu? Chạy make install, chạy strip binary. Ok, đấy là cách mình đóng gói package đấy lại và sau đó mình sẽ include vào cái image của mình. Again, simple, declarative và reproducible. Và như mình nói này, hai cái S-bomb quality bởi vì họ build from source. Đây là S-bomb quality cao nhất có thể rồi. Đây là một ví dụ mà mình so sánh cái Nginx official image trên Docker Hub và một cái image build trên Wolfi base. Mọi người thể thấy khi mình scan cái bản, khi mình làm cái slide này là cái vài hôm, mình scan cái image list của Nginx, nó có 166 cái CV. Một trong cái đầu tiên mọi người nhìn thấy nó là apt. Nginx có cần sử dụng apt trong runtime không? Không hề, đúng không? Nhưng với cái approach của Docker họ chọn là không giống như Decentralized, đúng không? Họ include tất cả những gì mà cái base của Debian có vào. Thì tại sao tôi lại phải quan tâm đến vulnerability lỗ hổng bảo mật của apt trong khi tôi không cần đến nó, đúng không? Với Wolfi họ chỉ include những gì họ cần mà thôi. Và họ sẽ cố gắng fix toàn bộ vulnerability của họ nếu có. Đấy, gần như mình đạt được cái con số là 0. Versus này, bên này 160 mấy cái image. Ok, thế thì sau khi mình build được một cái set image như này rồi thì làm gì tiếp theo? Bởi vì là mình đưa cái image, ví dụ như tôi có phiên bản Nginx 1.0, tôi đưa cho các đội phần mềm, đúng không? Nhưng mà vulnerability nó sẽ bắt đầu tăng dần hàng ngày, đúng không? Cái kết quả mà scan hàng ngày của các bạn ạ, nó chỉ valid trong một khoảng thời gian ngắn thôi, đúng không? Khi build xong rồi, đây chỉ là cái step 0 trong cái quá trình mà secure các cái workload của bạn thôi. Tiếp theo bạn sẽ phải update một cách tự động sau đó, nhưng mà cái goal mình đặt ra ban đầu là phải low maintenance nhất có thể, đúng không? Thì bên mình cũng sẽ build kèm thêm một con bot nữa. Khi các project, các đội dự án á, họ sử dụng các cái image bên mình, họ chỉ đánh dấu cái repository của họ, cái code của GitLab, GitHub, code repo của họ là tôi muốn enable auto update cái này lên. Con bot mỗi khi bên team mình mà có phát hiện ra scan hàng ngày, nếu phát hiện có vulnerability và fix được, mình sẽ review lại sẽ cập nhật cái catalog, đúng không? Nhìn catalog đấy, nếu mà đội dự án nào có sử dụng cái image đấy, nó sẽ mở ra merge request, chạy test nếu có của dự án, trong pipeline của dự án nếu có, và maintainer của các dự án của các đội phát triển đấy hoàn toàn có thể ấn nút accept vào là họ có thể back lại zero CV lại như bình thường. Ok, thì mình muốn quote lại một cái mình tin là the key to zero CV chủ yếu là cái ability stay close nhất as you can with latest read on version. Bạn không cần phải chạy cái latest. Mình không recommend mọi người chạy latest nha. Mình muốn recommend mọi người chạy stable. Nhưng ở cái ở đây là ability to stay close with the latest one. Bạn phải follow được cái latest một cách gần nhất có thể. Bằng cách nào? Trên production nhé. Bằng cách nào? Bằng cách chúng ta có nhiều layer của criteria variation. Ví dụ như kiểu mình vừa nói vừa nãy, khi một con bot mở một request ra để update cái base image, test nên chạy tự động. Đấy là một cái layer criteria variation, đúng không? Mình có chạy test, mình có build lại app. Đấy là một cái layer protection của mình để mình có thể tự động được, đúng không? Bởi vì nếu bạn không update ngày hôm nay, đến lúc nào đó có một cái CVE nào đó nó critical, bạn cần update, bạn sẽ không làm được một cách ngay lập tức. Thì đây là cái idea để stay close with zero CV nhất có thể. Mọi người có câu hỏi gì không?
Cho em hỏi một chút là cái Wolfi này ấy, thì nó có hoạt động giống như là Docker không? Ví dụ như là ở trong Docker file thì mình sẽ có một cái base image, đúng không? Thì, nhưng mà ở trong Wolfi này thì theo như em có thể thấy ở đây là nó không có base image. Như vậy thì là nó build ra cái image đấy kiểu gì?
Nó back lại cái câu hỏi là một cái container image nó gồm cái gì? Mọi người biết nó một cái tar file, đúng không? Đúng rồi. Thì trong cái tar file này có cái gì? Nó có squash, nó có base layout. Mọi người có thể tự compose cái document bằng cách lắp ghép cái file đấy thôi là xong. Thì ở đây họ có cái gì? Cái việc đơn giản của build một cái image là gì? Họ chỉ lấy các cái package về, mình define package ở đây. Và đó, đây là một cái base layout. Base layout là một cái rất là đơn giản, kiểu là một cái OS thì có sẽ USR bin, có sẽ USR lib, không? Nó sẽ có và tất cả mọi thứ, đúng không? Đây là cái layout này, đây là một cái package nó define thế. Thì nó chỉ là lấy các package về, nó compose lại thành một cái structure, tạo ra một cái tar file và thế là xong. Mình không có cái concept base image ở đây nữa. Cái mà nó ra, output của nó ra sẽ là một cái OCI container image mà mình có thể plug vào cái workflow khác của mình. Đây sẽ là base image của mình.
Anh có thể nói rõ hơn là cái như vậy thì nó compatible với cái gì không? Cái base đấy, có nghĩa là sau khi build từ cái base ra thì nó compatible cái gì? Ví dụ như kiểu hình dung là nó gần với AMPI nhưng bỏ đi cái gì, chẳng hạn như vậy. Với câu hỏi thứ hai là cái câu cuối cùng anh quất lại ấy, thì ví dụ như bên team bạn thì có cái rule, cái workflow build như thế nào để sao cho mà nó đảm bảo cái việc là anh luôn có cái build gần nhất với latest có thể không, các kiểu như nào để trong team như nào để có thể làm dễ không, vì cái việc ấy cảm thấy nó khá là phức tạp.
Cái compatibility như mình nói ban đầu ấy, ANPI là một cái rất tốt. Mình sẽ sử dụng chọn ANPI nếu như ANPI không chọn cái libc implementation của mình. Cái lựa chọn libc có mấy cái phổ biến là libc, đúng không? Và MUSL. MUSL khá ít team chọn, nó rất là minimum, nó secure nhưng rất ít team chọn. Và khi mình build mình link với MUSL á, thì nó không phải compatible các software mà mình build với glibc nữa. Thì đó là mình không thể mix giữa những cái như kiểu là em dùng cái ANPI, em down một cái binary build with glibc vào nó sẽ không chạy được, đúng không? Thì Wolfi team make một cái decision là họ quyết định sử dụng glibc thay vì MUSL. chủ yếu là để compatibility với các cái ecosystem một cách tốt hơn. Cái điểm thứ hai quan trọng ra là tôi output của tôi ra vẫn là một cái OCI container image, bạn sẽ plug in vào các cái workflow hiện tại của bạn. Nó là một cái base, bây giờ tôi output ra sẽ là cái base dùng tiếp. Bạn chỉ cần thay, tức là đa phần các cái case mà mình phải khi adopt cái Wolfi này, mình chỉ thay cái dòng đầu tiên là from cái image cũ Nginx bằng cái image mới từ Wolfi, và mình cố gắng là install đầy đủ package giống như kiểu nó feature compatible drop in được vào với các image cũ. Còn câu hỏi gì nữa nhỉ? Về ok. Build ra một cái image mà zero CV nó chỉ là step zero thôi, đúng không? Vulnerability hàng ngày nó sẽ bạn sẽ đọc tin sẽ tới hàng ngày họ sẽ phát hiện ra. Mình nên monitor các cái vulnerability đấy, mình sẽ scan cái image của mình. Có nhiều approach để manage cái này. Ví dụ như kiểu bạn hoàn toàn có thể scan lại cái image đấy. Đây là một approach chậm, mình không recommend. Với Wolfi họ có provide export. Export bạn tưởng tượng nó một cái file, nó là JSON đi chẳng hạn, ví dụ đấy. Bên trong tôi gồm package base layout version 1.0, Nginx 2.0, ví dụ kiểu đấy. Tôi bao gồm những cái đấy. Nó là một cái file khá là nhỏ, đúng không? Và bạn scan, bởi vì khi bạn scan á, chỉ cần biết là bên trong nó gồm cái gì, version bao nhiêu, mà nó có bị ảnh hưởng không, đúng không? Khi bạn có một cái VCB observability vào các cái đấy rồi, tức là cố gắng treat các cái, khi mình maintain các cái set image này, mình cố gắng treat cái nó như một cái phần mềm mình có observability vào nó. Metric ở đây sẽ là gì? Số lượng vulnerability mình có hàng ngày. Và nếu mình scan nó ra hàng ngày và mình nhận thấy là nó có bản fix upstream rồi, thì mình sẽ trigger review lại một cách tự động. Sau khi đó nó được push lên registry rồi, thì mình sẽ có thể plug in thêm các cái flow khác vào. Ví dụ mình có thể sử dụng renovate bot. Bên mình sử dụng một con bot tự viết digest bot để tự động mở ra, bởi vì cái logic compare cái tag của mình hơi khác một chút. Nhưng mà idea là bạn có thể sử dụng một con bot. Con bot đấy sẽ mở một request ra với cái dự án là tôi build cái mới rồi, nó sẽ scan cái registry đấy. Nếu có image mới mở ra trong dự án, mở request thôi, mở pull request thôi. Và nếu mà có dự án có setup CI, khi mà mở request được đúng không? Họ chạy test, thì lúc đấy nó sẽ click in các cái workflow như của bạn vào. Nếu mà xanh, maintainer hoàn toàn có thể chọn là ok, mở vào thôi. Đúng rồi, mình sẽ cố gắng hỗ trợ, mình cố gắng follow theo nhiều nhất. Mình aware là mình có vulnerability. Đầu tiên đấy, cái key để có vulnerability là bạn phải biết cái workload của bạn có bị ảnh hưởng không nào. Nếu bạn không biết workload bị ảnh hưởng không, khi nào bạn cần phải view lại image, đúng không? Và cái thứ hai là follow được theo nó bằng cách là mình sẽ có nhiều cái chốt chặn để bảo vệ an toàn. Ví dụ kiểu mình tự động chạy test khi mình mở request ra. Nếu mà test xanh thì maintainer cũng sẽ tự tin hơn là ok, nhân nó vẫn build được, vẫn chạy được kiểu đấy, thì họ sẽ tự tin khi mở hơn. Đấy là cái capability để giúp mình follow theo cái latest, cố gắng follow. Nếu chạy được theo latest, ok, tốt. Nhưng mà nếu mà chỉ chạy theo mà kiểu close to latest cũng được. Đúng rồi, đó là lý do tại sao mình cố gắng là mình sẽ có nhiều layer criteria validation, mình sẽ cố gắng nhiều lớp để bảo vệ protect các cái đấy.
Vâng. Anh cho em hỏi một chút là cái kiểu như chắc là nhờ anh kiểu như ghi advice là mình sử dụng Wolfi này cho những cái application của các cái service gì ấy. Ví dụ như là theo như em hiểu thì cái vulnerability có thể chỉ bị exploit khi cái service là always up, đúng không? Thì cái attack surface nó always là visible ấy. Còn những cái service chạy kiểu như serverless thì có cần tức là cái câu hỏi của em là kiểu như những cái nhóm service gì thì mình có thể kiểu như priority first là khi mà mình explore sử dụng Wolfi này để giảm vulnerability.
Ok, cái idea ở đây á, nếu bạn nó có hai cách. Khi bạn mà có nhìn thấy một cái vulnerability mới, đúng không? Bạn sẽ phải phân tích nào. Cách approach đầu tiên là bạn phải phân tích nó có thực sự ảnh hưởng đến không. Risk analysis, giả sử nếu nó có ảnh hưởng tới sẽ làm gì, đúng không? Có fix available chưa, đúng không? Hoặc một approach khác, bản patch đấy đã được release bởi maintainer rồi, tại sao chúng ta không apply bản patch đấy luôn, và chúng ta có nhiều cái lớp test khác, thì chúng ta sẽ không phải quan tâm đến phải phân tích là nó có bị ảnh hưởng hay không. Đấy là hai approach nha. Wolfi chọn approach thứ hai, mình cố gắng nếu mà có bản patch available và có release available rồi thì mình sẽ patch đi. Tại sao phải quan tâm là phân tích xem nó có bị ảnh hưởng hay không nếu chúng ta có thể vá được luôn. Thì nó là gì? Nếu vá được, vá luôn. Và chúng ta sẽ có các cái lớp validation khác để bảo vệ cái workload chúng ta là đảm bảo nó vẫn chạy được. Ok, nếu mọi người câu hỏi gì khác thì anh sẽ hang around bên ngoài một chút, nếu mọi người câu hỏi gì thêm. Thời gian đã hết rồi. Ok, cảm ơn mọi người.
I'm connected with you on LinkedIn. So anytime if you want to clarity, this would be. Yeah. So this is what we do. So, I'll send you a link.
Yeah.
You can take a look at the service manager. It's similar to we use. We have enterprise support. I'll send you a link. You can take the question. You can ask them if they have any questions.
So for our last talk, we have Pratik Chagrut, who is speaking about harnessing eBPF with next-gen security tools for Kubernetes.
Hello everyone. My name is Pratik Jagrut. These are my social handles, and if you want to connect me on LinkedIn, you can just scan the QR code. Today I'll be talking about eBPF and Kubernetes, how eBPF technology can be used to increase the security of Kubernetes cluster. So does anybody here know about eBPF? Can you hear me? Uh, Sorry, should I repeat again? Oh, it's fine. So today I'm going to talk about the eBPF and Kubernetes clusters. So how using eBPF we can increase the security of Kubernetes clusters. Anybody knows here what eBPF is? Yeah. So this is the general definition of eBPF from eBPF documentation. It's a technology that allows you to run a sandbox program inside a kernel. So basically, kernel is a very delicate part of any operating system, and if you mess up there, then whole system gets crashed. So it's really hard to run anything particular inside a kernel if it's not a part of its source code or if it's not a Linux module. So basically, before eBPF, there was a BPF. It's called a Berkeley packet filter. It was technology used for filtering a network packet at the kernel level. But nowadays, it does much more than just packet filtering. So it has been extended. Now it can be used for security, network packet filtering, observability, and whole other stuff. So why do we need eBPF basically? Has anybody ever wrote a kernel code here or maybe contributed? So basically, then you know that developing a kernel code is really a hard task. I mean, first of all, if you have any feature idea, then you need to convince the community that this is a good feature and it will be widely used by many other people, many other companies. And secondly, you need to be a good programmer in C, and basically because while adding any code in a kernel, you need to be sure that you are using a right programming models just for following a security, and then you also need to make sure that your code does not lags the overall performance of the kernel. And third, the kernel code base is very huge. I mean, if you just go over the GitHub and see the Linux kernel code base, then you will see like it's a universe. It's always expanding. So this is just a general development flow for a kernel, like any other software development. If you have new feature idea, you will just discuss within a community. Then it goes through a design phase, coding, submission. So it's like every software development procedure. And even after the release, after it's most like 3 to 4 years later, any feature released will come into the production. So no companies right now uses the latest kernel version of for the production. So these are the issues with the legacy coding factors, which eBPF manages. eBPF so basically makes a kernel programmable. That is, if you have a custom feature, suppose if you have to write uh, any tracing packaging system, or maybe you have to write a program to just list out the processes on the machines. You can do that through eBPF. You do not need to go through the kernel programming. So how do we write eBPF program then? So basically, first of all, eBPF program are event driven. So in kernel, anything happens through the event. Suppose if any new process is run, then there is an event which gets a call, and then to that you can attach your particular eBPF program. So whenever in future that event is again called, your programs get eBPF programs can run. So basically, these events are nothing but hooks or probes. Also, we call them attachment points. Your eBPF program can be attached to the K probes, which are kernel probes. U probes are user space probes. Trace points, XCPs are for your networking and then load balancing stuff, and events for your performance and metrics. So eBPF programs are basically in two spaces. One is user space and one is a kernel space. User space applications are written in Go, C++, Rust, and Python as well, whereas the kernel space application has to be written in C. That also is in a restricted C. It does not have all the features of a C line. So whenever you write kernel space eBPF program, it goes through some phases. It goes to the verifier first. It checks if your eBPF program is actually good to run. I mean, you have not left any dangling pointer or anything, and it will not crash. It makes sure that this program will not crash your kernel. JIT is a just-in-time compiler, and then maps are for storing your data. So whenever you collect any data from a kernel, that need to be stored somewhere in some kind of a data structure, and in kernel we use a maps for that. And from there it goes to OS runtime and it gets attached to the hook. And these are the some eBPF projects written over there. Cilium, Falco. These are majorly used eBPF projects in Kubernetes community. So this is a basic example of a kernel space code, how you can write. So this is a sec function, which is a predefined function in BPF libraries. So there you pass the hook or a trace point. So I'm here passing a trace point of a syscalls, which is sys underscore enter underscore xv. So whenever any process is run in your system, this particular trace point gets triggered, and this is the function which I have defined, which will be called upon whenever that particular trace point is triggered. So how does it help with the Kubernetes then? So basically, Kubernetes is just a cluster of nodes, and every node has their own kernel. And using eBPF, you can increase the runtime visibility of the things. These are the categories where we can use eBPF, like container security with eBPF, threat detection, and real-time monitoring system, where there are a bunch of projects which are using eBPF for observability and security monitoring in Kubernetes. So I'll be just giving a short demo here. This is just one of the security project called Tarian. It's a very new project. It's not known by it's not known to many people. It's one of my pet project. I'll just be giving you a live demo here. Can you hear me if I keep the mic down? Can you still hear me? Uh, so this is my Kubernetes cluster up and running. I have all the namespaces which by default get created. Then these are the pods running by the Tarian system. Thank you so much, sir. These are the pods which are up and running by the Tarian system, which are needed by my project. Then to show just to show that this is just an Nginx application which I'm just demoing as a production level application that we are using. So now I'll just add a constraint. So now, this is a Tarian add constraint command. Using this, I am just telling my cluster that I just need to run 3 processes, which is POS, Tarian pod agent, and engineer. Any other process other than this will be a malicious process, and it should not be run. So I'm just adding it to the my constraint. You can see that we have successfully added. So match labels, if you guys know Kubernetes, then you know the labels and selectors in Kubernetes, how they work. So whenever whenever any malicious container is run inside particular using this label, then which is not process which is not added in the POS, Tarian pod, or HNNJS, it should be reported as a malicious process here. I'm adding a watch over here event. So if I run any other process using kubeexec, hopefully it should run. So I run a sleep process here, which was not the process were not allowed. Which sleep process was not allowed, and still I tried to run it, and it ran in a container Nginx, and now it has been reported as a violated process. This process does not belong to this container, and it might be malicious process. So this was a small demo for the project which I've been working on. That's all from my side. Questions? It was really short and small talk. Yeah.
Yes, and with eBPF, do you see the kernel having any Rust support in eBPF in the future?
I actually don't work on Rust. I'm a Go developer, and I mostly same here. So I mostly know about the Go community and how that. So maybe we can watch a community channel for the Rust updates. Thank you, guys. Thank you so much.